Shall we go live? Ali sir? Okay, thank you.
Live. So, 1 minute, sir. 1 minute, Bagli, sir.
Okay.
Till live is not streamed.
It is started live streaming.
Okay, okay, okay.
Thank you.
Welcome to the School of Engineering at Dayanand Sagar University, main campus, Arohaldi, Kanakpura Road, Bangalore. A place that values research, innovation, and creativity. Our industry-aligned curriculum offers a blend of theoretical knowledge, practical experience, academic projects, and internships for a rewarding career in engineering. With an interdisciplinary approach, you can explore your interests by selecting open electives. The on-campus innovation labs, led by professors of practice, provide immersive learning and expertise to find the best solutions to real industry problems and give a different dimension to the students' mini and major academic projects. Our Center for Entrepreneurship supports startup opportunities and provides a perfect platform to launch your next big idea into successful ventures. We also prepare you for advanced studies in the latest futuristic technologies. Our BTech programs offer the perfect combination of academic rigor and functional experience in this ever-evolving technological landscape of the future. Experience a whole new world of academic excellence in a global environment. Dayanand Sagar University. Live the dream.
Dear students, welcome to Dayanand Sagar University's Daya. Today we are going to have chemistry session. The topics are going to be haloalkanes, haloarenes, coordination compounds, classification of elements, D and H block elements. Ravi Shankar sir, are you ready, sir?
Yes, sir.
You can share your screen and I'll hand over the session to you, sir. Your screen is visible, sir.
Okay, shall we start then?
Yes, sir.
Okay.
And sir, students will put their questions in Q&A. Please keep checking.
No.
Thank you. Thank you.
Dear students, welcome back to our sessions on chemistry. Okay. And today I will be discussing mainly 3 important topics. Okay, and also one topic from first PUC also. Okay, which will be a fundamental for many other chapters. So I have taken it together. So first we'll start with haloalkanes and haloarenes. We'll start from here. Because this particular chapter will be having 2 to 3 questions. All this chapter, what I'm going to discuss, okay, will be having around 2 to 3 questions. Even deep blend F block also. So almost we'll be getting around 6 to, I can say, up to 8 or 9 questions. So there may be plus or minus 1 or 2, it will be there. And classification of elements, it belongs to mainly first PU portion. Why I have taken this also is that because this is a fundamental, which will be helpful for all other topics. So let us start with first one, haloalkanes and haloarenes. We'll start from here. So what are the things we have to study here? First is that we'll start with classification. So what are the classification we have to study? I just take a pen. There are two classifications mainly based on number of halogen atoms. So based on number of halogen atoms. And the second one is based on whether the halogen attached to sp2 carbon atom or sp3 carbon. sp2 or sp3 carbon atom. Bagli sir, are you there?
Yes, sir. Yes, sir. Tell me.
But there's seems to be some kind of a problem in video. Can you see?
There is no problem as I am able to see you.
Okay.
But only your screen is got stuck up.
That's
But the screen which you are sharing, that is okay. You can just write one, sir.
yeah. That I am writing it. It's not a problem. Yeah, can you
That's
see
not a
it?
problem. Only your visibility is not there. That got stuck.
Okay. Okay.
But whereas whatever the material you are sharing, that is okay.
No problem. No problem. That's okay.
Okay.
Okay. Because we don't have that kind of a technical things to make everything right now. Let us go ahead. Okay.
Okay, sir. Okay.
So we can classify this particular alloalkanes and alloarenes, okay, or what we can call it as organic halogen compounds. What is organic halogen compound? Organic compound containing halogen, under which we will be studying alloalkanes and alloarenes. We can classify based on two criteria.
Sir, may I ask Ali, sir, what is the problem? I'll just 1 minute ask.
No problem. Because as long as they're able to see the slide and my writing, that is enough.
Okay, no problem.
Okay.
Sir.
But in the meantime, in the background, you can make inquiries. No problem.
Ali, sir, if possible, you can have a look, sir. Okay, sir, no problem.
Okay, right. So let us come to first classification. Classification based on whether the halogen attached to sp2 or sp3. This is quite very interesting and important also. Many students, what will happen is that they start their topics all of a sudden from alloalkanes and alloarenes. I wish first thing is that they should go through classification. So what is allylic halide? Where you can see the halogen is attached to a carbon atom which is having a sp3 hybridization. So in allylic halide, the halogen is attached to sp3 carbon atom. And in alkyl halide also, the halogen is attached to sp3. In benzylic also, halogen attached to sp3. Whereas in vinylic, the halogen attached to double bonded carbon, that is halogen attached to sp2. In same thing in alloarenes also. So what picture it gives us? Very simple. If the halogen is attached to sp2 carbon atom, those compounds will be less reactive because they will be having a partial double bond. You cannot break it. You cannot break it easily. The reaction will be slow. Whereas in the halogens having a where halogen attached to sp2 carbon atom, there will be more reactive. Easy to replace. Easy to replace. Which are the category under which halogen attached to sp3? Allylic, alkyl halide, and benzylic halide. Okay, the alkyl halide is known as what? This itself is known as alloalkane. That is our topic. And the aryl halide are known as alloarenes. So this is the topic what we are supposed to discuss. We'll go to one more classification based on number of halogen atoms. Which are those? Sir, if you're having only one halogen, monohalides. If you're having two dihalides, 3 means tri, tetra. Many means we call it as a polyhalides.
Sir, you can stop and reshare, then it will come. Or otherwise, you can put off your video. Your internet must be slow. That is the reason this, yes, sir.
Yes, maybe. Shall I'll do it once.
Yeah, you can put off your, yeah, now it is.
Now it's clear, no? Yeah, right. You are right. You are right.
Yes, sir.
Good. So, based on number of halogen atom, we can classify it as monohalide, dihalide, trihalide, tetrahalides, and also into polyhalides. We call it as polyhalogen compounds. Under this, we study dichloromethane, we study about chloroform, we study about carbon tetrachloride, we study about freons, we study about DDT, All those topics comes under this polyarism part. Coming to this one, dialytes. In this dialite, there are two types: geminal dialite and vicinal dialite. What is geminal? Where the halogen attached to the same carbon atom. In vicinal, the halogens are attached to adjacent carbon. Please remember this part. So this is the two classification what I want you people to know. Coming to preparations. So what are the preparation we have to study? There are so many preparations are there. But what I want you people to know is that whatever is given in NCERT textbook, please don't miss it. This is our important one. This is our reference. You study one or two extra, no problem. But you should not study less than what NCERT has given. Sir, I want to study 4 or 5 reaction extra, that's left to you. No problem, you can study it. But make sure that you are studying what is there in the NCERT. Okay. So let us take the first one. What is that? From direct halogenation, can we prepare alkynes? Yes, we can prepare it. Because it is a free radical mechanism. We can do chlorination, halogenation, fluorination. Among these, fluorination is more reactive than chlorination, bromination, iodination. But fluorination, we don't do it because the reaction is explosive. Iodination, we don't do it because it is reversible. So most of the textbook, we come across chlorination and brominations. Okay. There seems to be some problem with my video. You have to bear with it.
Sir, you just off your video. Just your audio will be okay. This will be okay.
Shall I switch?
You stop your video. Yeah.
No, okay. No problem.
Okay, sir.
Okay. So among this one, sir, among the halogenation, okay, which molecule is more reactive? Look at it. Allylic is more reactive than tertiary. Tertiary is more reactive than secondary. Secondary is more reactive than primary. And then methane. Then important one is addition of HX to alkene. It also gives you all alkenes. It follows two rules. One is Markovnikov rule, another is anti-Markovnikov rule. One is Markovnikov rule, another is anti-Markovnikov. Markovnikov rule is an electrophilic addition, whereas anti-Markovnikov rule is a free radical addition. And anti-Markovnikov rule is applicable only to HBr. Remember this. No other things. Whereas for Markovnikov rule, anything you can take. HCl, HBr, HI. Okay. We can carry out reaction with all the halides. But for anti-Markovnikov rule, it has to be HBr in presence of peroxide. So among the halides, HI is more reactive. Because bond dissociation enthalpy is very less. Bond dissociation enthalpy is very less. Next, we'll go to one more reaction. What is that, sir? We can prepare it from alcohol also. How to prepare it from alcohol? So how to prepare it from alcohol? By treating with phosphorus halides, like what? PCl3 or PCl5, we end up getting RX. If we treat with HCl, we get RCl. If we treat with thionyl chloride, we get RCl. This reaction is also known as Darzon's reaction. So what is Ansdeiker reaction? When you take a silver salt of fatty acids and when you treat with bromine, we end up getting alkyl bromide. This kind of reaction we call it as a Ansdeiker reaction. Then coming to Finkelstein reaction, you studied about halogen exchange method, Finkelstein as well as Swartz reaction. So what is Swartz reaction? When you treat alkyl chlorides with what are with inorganic fluorides, you end up getting RF plus AgCl. This kind of reaction is known as Swartz reaction. What is Finkelstein? Where you convert alkyl halides like alkyl chlorides by treating with sodium iodide into alkyl iodide. This kind of reaction is known as Finkelstein reaction. We also call it as halogen exchange method. So let us study once again. Wait a minute, I'll just clear this. Okay. Coming to physical properties. So what are the important things we have to study in physical property? Very important is this dipole moment. Alkanes are having a polarity. For example, if I take CH3Cl and Cl is highly electronegative, so it will be having a slightly negative charge when compared to carbon. So this bond we call it as a polar. So they have a dipole moment. Who is more high? Sir, alkyl chloride is higher, sir. Then comes fluoride, bromide, and iodide. Remember this. This is about polarity. Then important one is boiling point. So boiling point, remember, depends on number of carbon atom. Already we have discussed. Is proportional to the number of carbon atom. More the carbon atom, more the boiling point. And boiling point is inversely proportional to branching. Is inversely proportional to branching. So is inversely proportional to branching. So among the halogen, BRA is more boiling point it is having. Why, sir? Because boiling point is proportional to size. And solubility, next one important. Alloalkanes are even the polar, they are insoluble in water but soluble in organisms. Why, sir, insoluble in water? Or least soluble in water? Because they cannot form hydrogen bond with water. They don't have sufficient energy to form hydrogen bond. Next one. Let us take bond strength. Already told you the bond strength of Ci is very less. So the bond strength of Ci is very less. Who is very strong? CF. So who is more reactive? The alkyl iodides are more reactive. Why more reactive? You can easily break it. Sir. Next one. Let us go to chemical properties of this particular alloalkanes and allorenes. Just one second, I will try. Yes, you can get it. I'll take a pen. It becomes easy for me to explain. Coming to nucleophilic substitution reactions, we call it as NSR reaction. Very, very important. Why they give nucleophilic substitution reaction? Already I told you, our alloalkanes are what? So they are polar in nature. And the halogens can be easily replaced by another nucleophile. So it can be replaced by nucleophile. So we call it as a nucleophilic substitution reaction. So if it reacts with QH, so they give alcohol. If they react with moist silver oxide, also alcohol. But with dry silver oxide, they form ethers. With silver sodium alkoxide, they form ether again. It's called as Williamson ether synthesis. Remember, but here the alkaloid what you take should be always primary. You cannot take tertiary. Always primary. Then what will happen? When they react with the alkyl group having the sodium, the alkyl group will replace sodium and alkyl group is added to that. Alkyl compounds, this is alkane. Then it reacts with ammonia to form ammonium salts. Can react with silver salts of fatty acid to form ester. It can react with KNO2 to form what? What is this compound? We call it as a RONO. Whereas if it reacts with HNO2, you get RNO2. We call it as nitro. And this is called as nitrite. KNO2 is called as nitrite. Like with AgCN, it forms isocyanide. Whereas with CN, it forms a cyanide. This is also very important. Why? Because AgCN is a covalent compound. Next, What will happen when they react with alcoholic KOH? Sir, elimination reaction takes place. What kind of elimination? It is called as beta elimination. When beta elimination takes place, the product is always alkene. Alkene. It follows which role? It follows Sedgwick rule. It follows a Sedgwick. And if it undergoes reduction, any reducing agent you can use. They form alkanes. Say, for example, Ra undergoes reduction, it forms alkane. Reaction with metals, reacts with magnesium to form what? Lunar reagent. Reacts with sodium to form IR alkane. What is reaction we call it as? It can also react with what? Sir, aryl halide and sodium metal to form alkyl aryl compound. We call it as a Wood-Spitting reaction. So these are the important parts. Then coming to nucleophilic substitution reactions. There you have two types of nucleophilic substitution reaction that already are studied. One is SN1 and SN2. This is very important. You should remember this one. And in SN1, you know that it is a two-step mechanism. The important intermediate is a carbocation. And among carbocation, tertiary carbocation is more stable than secondary and primary. And remember, electron donating group stabilizes carbocation. And more the benzene, more the stability. So more the benzene, more the stability. And here in this particular SN1 reaction, we say racemic mixture is formed. So what is racemic mixture? You'll be having a equal amount of D and L. Equal amount of D and L. Why this happens? Because you know that nucleophile can attack this particular carbocation from either side. So which alloalkane is more reactive? So tertiary alloalkane is more reactive than secondary, than primary. So this is the difference between SN1 and SN2. Please remember this one. It will be very helpful to us. Just go through it. Very important one. And remember, in SN1 reaction, we need polar protic solvents. Whereas in a SN2, it's a non-polar. Remember, polar aprotic means it is a non-polar cell. Non-polar means acetone. Remember these names: DMSO, dimethyl sulfoxide, acetonitrile, DMF, dimethyl formamide. We call it as dimethyl formamide. And I already told you it takes place in two-step, and intermediate is carbocation. But here it is a transition state. Primary alloalkane is more reactive. Here primary is more reactive. Here tertiary alloalkane is more reactive. Rate of reaction: tertiary alloalkane is more reactive than primary, whereas here primary is more reactive than tertiary. And here this can proceed through weak nucleophile, whereas it requires a strong nucleophile. And I told you in SN1 respiration takes place. Means there is retention and inversion more. And here only inversion will take place. So let us understand few things about this allorenes and polyurine compounds. So what is aryl halide? Where halogen is directly attached to benzene. We call it as aryl halide. What is a benzylic halide? Where halogen is attached to sp3 carbon atom. That means side chain. We call it as a benzylic halide or aralkyl halide. So coming to these polyurine compounds, I told you have to know a little bit about those things also. So chloroform, already I told you. Earlier it was used as an anesthetic, but nowadays we don't use it. Why, sir? When exposed to air, this chloroform becomes poisonous gas called as poison. So we don't use it. We don't use it. Next, coming to iodoform. Iodoform is used as a disinfectant and it is also used as an antiseptic. Freons are chlorofluorocarbons. These are the chlorofluorohydrocarbons of chlorine and methane and ethane. Next one, DDT. It is a diphenyl trichloromethane. Okay, it is used as insecticide against the mosquitoes. Teflon, we know that one. It is used for making non-stick cookwares. Okay, all these are what? These are all becoming a toxic chemical. And also remember dichloromethane. Where we use it? So dichloromethane, we use it as a cleaning agent. We use it to remove the stains. It is a sweet-smelling liquid, but very dangerous because very toxic. It affects our central nervous system. It affects our skin. Coming to few properties of aryl halide. So what are the properties of aryl halides? Remember this one. Here, boiling point generally, what will happen to boiling point, sir? Increases with increase in size of aryl group or halogen atom. And melting point of the para isomer is more than the ortho meta is due to packing efficiency. Say para dichlorobenzene will have a streamlined body and they can have a very close packing. So melting point will be very high. And due to resonance of in chlorobenzene, the CCl bond is having a partial double bond character. We cannot break it easily. Two important reactions are nucleophilic substitution reaction and electrophilic substitution reaction. First one, let us take nucleophilic substitution reaction. This reaction will not take place at low temperature. No, at low temperature. Because we cannot break the CCl bond. They are having a partial double bond. So we cannot break it easily. But at high temperature, we can carry out the reaction. So high temperature, we can carry out the reaction. And especially electron withdrawing groups will increase the NSR reaction. So if more NO2 group is there, this reaction can take place even at warm water only. Which reaction? Replacement of chlorine by OH will not take place at room temperature. Whereas if you add a NO2 group to that, now the reaction can take place even with warm water only. Last one, ESR reaction. What is ESR? Electrophilic substitution reaction. Very important, this one. For example, chlorobenzene undergoes chlorination. What is chlorination? Addition of Cl. In terms of what? AlCl3. And here the electrophile is Cl plus S. So what are the products obtained? Sir, ortho and para. Why ortho and para? Due to plus-R effect of chlorine, we call it as. Due to plus-R effect of chlorine molecule. And remember this reaction, fatigue reaction. What is fatigue reaction? Sir, chlorobenzene reacts with Na to form what? Biphenyl compound. And this kind of reaction is known as fatigue reaction, we call it as. Let us take some questions. I have taken all the questions from previous CET and NEET. Let us discuss it. Methyl bromide is converted into ethane by heating in ether medium with what? What we can take? So what he has done is converted methyl bromide into ethyl. Means it is having one carbon. One carbon has become two carbon. That means higher alkane. So it has to be Wood's reaction. So Wood's reaction means we have to take sodium. What may be the option? Plus C. C is the option, sir. Which of the following compound is expected to be optically active?
Sir, your voice?
Yeah, is it audible?
Yeah, now it is audible.
Okay. Which of the following compound is expected to be optically active? There are two conditions for optical activity. What is that? You need to have chiral carbon atom. So there should be chiral carbon atom. And then R need to have chirality. You need to have chirality. Our one more condition is that no plane of symmetry. No plane of symmetry. So which compound can follow these things? That we have to find out. What may be the option? We have to write the structure. One by one, we have to write the structure. Let's start writing the first structure. Let us take A. What is A? How it looks? He says CH3 twice. Means there has to be two CH3 group, then CH-CHO. So is this a chiral? No, because there are same group attached to carbon. So this is not chiral. H we can write it here. So this is not a chiral. This is not. Why? There are same group is there. This is not chiral. Let us that second you try. There is also no. Let us try third one. What is third one? C. Let us take CH3, CH2. Then you're having CHBr. Then what is remaining? CH. And if you look at this one, I will change the color. This carbon, if you observe, it is attached to four different groups. And this carbon is known as chiral. And one who is having a chiral carbon will give you optical activity. So option it has to be C, sir. Option has to be C. Take a screenshot. Yes, option is C. Next one. The organic compound which produces a bluish green colored flame on heating in presence of copper is. What may be the option? When you say in terms of copper means, it is nothing but a Bilstein test. So what is a Bilstein test? Is a test for halogens. So it is a test for halogen by using a copper wire. Where is the halogen is present? Benzaldehyde? No, sir. Benzoic acid? No halogen. Aniline? No halogen. So option A should be there. How they do it? They will take copper wire, just heat it till it imparts no color. Till it imparts no color. Then again cool it and then immerse in compound, immerse in organic compound. And then put it in Bunsen burner. Then if it gives a bluish green flame, that means halogens. So it has to be chlorobenzene. Let us check it out. Yes, sir. Option A is right. Next one. How many chiral carbon atoms are present in 2, 3, 4? Trichloropentane. What is a chiral? Already I told you. Chiral means you should have a 4 different groups. You should have a 4 different groups. 4 different groups. Let us write the trichloropentane. What is pent? So 1, 2, 3, 4, 5. 2, 3, 4. This is 2, 3. Then what is the valency of carbon, hydrogen here, carbon here? Sir, 4. So 1 hydrogen plus. Let us write the what is the structural formula? Then what will be the chiral? One by one, we'll check it out. I'll change the color. So let us take this one, C. What is there here? Hydrogen is there, sir. So these are all hydrogen. So this cannot be chiral. No. Then let us take this carbon. When you take this carbon, this becomes a CH3, this becomes S, this becomes Cl. This entire thing becomes one group. So it is having a one different group. So this is chiral. Like that, you find what are the other molecules which are chiral in nature, which are other atoms which are chiral in nature. What is structure I have written? I have written the structure like this. Now where I have written? This is the structure what I have written. So if you look at this carbon atom again, I will take the pen. So if you look at the carbon atom again. So this is becomes a one group, H becomes a one group, Cl becomes a one group, the entire thing becomes another. So what will happen? So we get two chiral carbon. Next one. So is it right? Let us see, check it out. Yes, sir, it is right. There are two chirocarbons. Decomposition of benzene diazonium chloride by using copper chloride HCl to form chlorobenzene is known as what? This already we have studied. Where we have studied? We have studied it in amine, sir. In benzene diazonium salts, we have studied. What is a benzene diazonium salt? A benzene with N2Cl group. This when you treat with copper chloride and HCl, what will happen? It gets converted into chlorobenzene plus N2. And this reaction is called as what? Sand-Maes reactions. Let's go to the next question. How many optically active stereomers are possible for butene 2,3-diol? Butane 2,3-diol. Again, all this question belongs to what? Optical isomerism. Optical isomerism. How to find out number of optical isomers, sir? Very simple. By using the formula 2 to the power of n, where n is the number of chiral carbon atom. Number of chiral carbon. What is chiral? Attached to 4 different groups. Let us read this structure. Butane 1, 2, 3-diol. What is but? 1, 2, 3, 4. He says 2, 3 diol. Diol means there should be OH. Diol. So this has to be CH3 and this has to be H. And this has to be CH3. So how many chiral carbon atoms, if you observe it properly, look at here, this carbon is attached to 4 different groups. Like that, if you take this carbon, it is also attached to 4 different groups. So there are 2 chiral carbon atoms, sir. N is equal to 2. N is equal to 2 means 2 to the power of 2, sir. That has to be 4, sir. Next one.
Sir, students are putting their options in Q&A.
Oh, okay, right. Very good.
You can keep checking, sir.
Yeah.
Answers they are putting.
Yeah.
Okay.
And here, look at here. Sir, here, as I told you, 2 to the power of n is equal to what? 4, sir. Is equal to 4. So we got 4. Number of optical isomers are 4. Then atom should be B, no? Then why they have given A? Because in optical isomers, we get something called as mesocompounds. So what is mesocompound? I told you. What is a mesocompound? They have a plane of symmetry. What is a plane of symmetry, sir? A imaginary line where molecules can be divided into 2 equal parts. Look at here. I can divide this molecule into 2 equal parts. This is one part and this is one part. What will happen? The optical activity gets cancelled. Sir, optical activity gets cancelled. So you have to make 4 minus 1 to account for the miss account. We get 3. 3 means, so it is, although we get answer as 4, but we have to make 4 minus 1. So option is yes, sir. Option is A. N-propyl bromide on treating with alcoholic KOH produces N-propyl bromide on treating with alcoholic KOH produces what? Yeah, Sneha, Arsha, Aditya. Please tell me, what is the option? Sir, how to do it? Just you have to look at the question. It represents which topic? When you say alcoholic KOH, so it is all about beta elimination. Beta elimination means what you get? So always we end up getting alkenes. Alkenes. That's it. No need to read the equation because look at here. In all this option, who is the alkene? Only D is alkene. You can save a lot of time. You can save a lot of time like this. Let us check. Is it right? What is propyl? Propyl bromide means CH3, CH2, CH2PR. This is called as N-propyl bromide. When I treat with alcoholic KOH, what will happen? Dehydrogenation takes place. What is that? The K removes Br to form what? KBr. From the next carbon, that is beta carbon atom, the OH will remove. What will it remove? OH and H from the beta carbon atom. It removes one water. So water is also removed. So what is remaining now? What is remaining is CH3, CH, double bond, CH. So propene you get it. Got it? Very good. Sneha, Aditya. Aditya, why you have taken B? Sridhar as A. Sushmita, good. D. Next one. The organic compound on eating with copper oxide produces CO2, but no water. The organic compound may be. Give me answer quickly, all of you. You have to give the answer. Give me answer, no problem. Any answer. What may be the answer? Still, I'm not getting any answer. All of you should put some answer. Very good. Sushmita, Anonymous, Mohammed. A. Chloroform. Sneha, D. Sridhar, A. Harsha, D. So how to analyze? Very simple. He says the organic compound does not produce CO, does not produce water. No water. Means H2O is not there. How you get H2O? You get H2O from hydrogen. So in your compound, hydrogen should not be there. What is methane? Sir, hydrogen is there. And chloroform. Sir, hydrogen is there. Ethyl iodide. CH3Cl2. Sir, iodine is there. Hydrogen is there. But in last option, which one? In carbon chloride, there is no hydrogen. When there is no hydrogen, The organic compound is carbon tetrachloride. D is the option. The organic compound, same thing. D is the option. Next one. A dibromo derivative of alkane reacts with sodium metal to form an alicyclic hydrocarbon. Derivative is what it is. What will be the option? It's almost like a Woods reaction. What will be the option? He says sodium metal. The derivative is what will be the derivatives? Ether iodide 1214-dibromobutane, Sridhar D, Sneha D, Lalit A. How it is? Very simple. Sir, definitely to form alicyclic compound, we need more carbon atoms. So ethane is not possible, propane is not possible. So only option is butane. How many butanes are there? 2 are there. Let us take 2. One is 1,4-dibromobutane. So what will happen, sir? So this is also valency of hydrogen is 4. So this is also CH. So when you treat with Na, Na goes out with NaBr. How many Na you take? 2 Na, you get 2 NaBr. So what is remaining then? CH2CH. Then CH2CH. And they form a cyclic structure. This is called a cyclobutane. And it is obtained by what? It cannot get it from 2,2-dibromobutane. It has to be diesel. Next one. A reaction of methyl bromide with aqueous sodium hydroxide involves what it involves. Methyl bromide is as I told you, is a primary alkyne. Is primary alkyne. And it says aqueous. Aqueous means the solution is polar. So what will happen? Is it SN1 or SN2? That's what he's asking. What will be the option? So if it is a primary alkyne, it gives you what? SN2, sir. SN2 means there is an inversion. That means option both C and D. Next one. I will clear it. The maximum number of possible optical isomers in 1-bromo-2-methyl cyclobutane is how many isomers are possible? You have to write the structure, then you get idea. So how to write the structure? You write first cyclobutane. What is cyclobutane? 4 carbonate. 1 bromo means there is a 1 bromine here. 2 methyl. There's one methyl group here. And if this is a carbon, definitely there should be 4 valency. Then that means hydrogen is there. So how many optical isomers? That depends on the number of chiral carbon atom. Which are the chiral carbon atom? This is a chiral carbon. This and this. So what is the formula? 2 to the power of n means 2 to the power of 2. So 4 isomers. Next one. Which of the following is not true for hydrolysis of tertiary butyl bromide with aqueous NaOH? What may be the option? I already told you. If it is a tertiary alkane, the reaction followed is SN1. SN1 means you should have carbocation. And when it is carbocation, which is preferred? Tertiary alkane is preferred. Everything is fine, sir. Then, and also remember, SN1, you don't need a nucleophile. It's a weak nucleophile is enough. That means what? Sir, the rate is proportional to only alkane, not nucleophile. So it does not depend on nucleophile. That's why it is a first order reaction. So let's check one by one. SN1, yes sir. Carbocation, yes sir. The rate of a reaction doubles when the concentration of alkali means nucleophile, is doubled. Tappu sir. When it does not depend, it cannot be. That is the option. All of you getting it? Please type yes if you are getting it. All of you. Very good. Please type yes if you are able to understand it. Good. I want all of you should type it. Yes or no? No also no problem. If you're not able to understand, put no. If you're able to understand, yes. I'll go through all the question papers now. Very good. Thank you, Amulya, Ramesh, Prasad, Mohammad, Sneha, Sridhar, Lalit, Sushmita, Pragna, Sridhar, Jagtap, Lalit. All of you should type it. Aditya, Monica, Bhagyashree. Very good. Next one. I'll remove this one. You have to tell me now. To obtain a propane nitrile RCl should be. What is propane nitrile? This one. Propane nitrile means there should be 3 carbon atoms. CH3, CH2, CN. You have to obtain a propane nitrile. So what we have to get? Already in cyanide, 1 carbon is there. Already in cyanide, sir, 1 carbon is there. So I need 2 carbon atoms. That's it. 2 carbon means what? Sir, already this is propane. No, this is not the answer. So methane, no answer. It has to be A. It has to be A. Let's check it out. Option. Yes, sir. A is the answer. Next one. Which of the following is not true for SN1 reaction? I already told you. Tell me what is the answer? Quickly, you have to tell everybody. Very good, very good. Lalit, D. Very good. Sridhar, Bindu, Sneha, Pragna, very good. Sujal, T. Ramesh, Pratap T. Sandhya. Yes, sir. Because SN1 means it is meant for what? Tertiary around cancer. Sir, SN1 we know that tertiary is more reactive than secondary, more reactive than primary. Everything is said, sir, but T mentions primary. That is wrong, sir. That is not true. Next one. The number of optical isomers of the following compound is, yes, everybody has to give me answer. I told you it depends on what? Chiral carbon atom. What will be the option? Yes, everybody has to give me answer. Very good, very good. All of you got it. All of you got it. Prasad, Anonymous, Sushmita, Sridhar, Sandhya. Very good, very good. Fantastic. You already got it. Which are chiral carbon atoms? So only there are two chiral carbon atoms. This one and this one. What is the formula? 2 to the power of n, 2 to the power of 2. That means D is the option. Meso compound do not show optical activity. I told you due to plane of symmetry. C option. Next one. Alkyl bromide reacts with sodium in ether to form 4,5 diethyl octane. The compound X is. Whenever we say sodium, that means it's a Woods reaction. That means it is a Woods reaction. What is a Woods reaction? Two molecules of alkyl halide react to form higher alkane. From higher alkane. What do you mean by that? If you take a 1 carbon, you end up getting 2 carbon. If you take a 2 carbon, you'll end up getting 4 carbon, right? He only says 4,5 diethyl octane. What is octane? So there should be 8 carbon atoms. 4, 5, 6, 7, 8. 4,5 diethyl. Okay. What should be the answer, sir? Look at here. How many carbon atoms we are having? Sir, 8 plus 4, 12 carbon we are having. 12 carbon means your alkyl should have 6 carbon. And if you look at here how many? 5 plus 3. Sir, how many carbon? 8. So it cannot be. So what may be the option? But there is a one branching, sir. So when branching is there, it has to be, sir, option D. Option D is. This is how it happens. Which of the following pairs are correctly matched? What may be the option? AGOH, aqueous, he says. Aqueous means we should get ROH. So it's wrong. AGSN means isocyanate, right? So KCN means we have to get R and C. That is wrong. Sodium means IR alkyl, right? So which is right? Second and 4 is right. Second and 4 means options. Next one. Cycloalkane formed when dibromopentane is heated with sodium is. I already told you, when comes sodium, I told you it reacts with what? Halogens. It removes this brominate. Say, Ravinger, how many carbon atom? Pentane. 5. 1,4. You're having bromine. What will happen when you treat with sodium? This NaBr is removed. When NaBr is removed, what will happen? So this carbon atom will join with each other to form a cyclic compound. What will happen? They join to form a cyclobutane. But there's a one carbon extra here. That becomes H. So there's nothing but CH3. There's nothing but what? Methyl cyclobutane. What is the option? Sorry, option A. Let us check it out, whether it is right or wrong. Yes, sir, right. Only methyl cyclobutane. A incorrect statement with respect to SN1 and SN2 mechanism for alkalides. Incorrect statement. What is incorrect? Let us state one by one. A strong nucleophile. Yadike, he says for SN2, right, sir? Aprotic means non-polar. It is right, sir. Competing reaction for SN2 is rearrangement. This is doubtful. Let us keep it like that. S7 reaction can be catalyzed by Lewis acid. Yes, Lewis acid means one who accepts electron. Weak nucleophile and protic solid. Protic means polar. Is good for S7. Yes, sir. This is all right. So what is the option? Option B, sir. Next. The element of the following compound can be in the increasing order of their boiling point is. Please do it. This is from 2015 CET. What was the option? I given you a clue. What is the clue I given you? Boiling point is proportional to what? Size. And it is proportional to number of halogens. What is bromophora? CHBr3. What is dibromomethane? CH2Br2. And bromomethane is CH3Br. And chloromethane is CH3Cl. So who is having the highest boiling point? Depends on, sir, number of halogens. Boiling point depends on number of halogen. Who is having more halogen? Second, sir. So second should be highest. Then should come fourth, sir. Then among bromine and chlorine, who is bigger in size? Bromine is bigger in size. So bromomethane should come first. Then comes third, sir. Or you can also write it like this. What I've written is from highest to lowest. That is decreasing order. Outright increasing order. Third less than 1, 1 less than 4. Second. What is the option? Sir, option C, sir. Option C. Next. The hydrolysis of optically active 2-bromobutane with aqueous NaOH result in the formation of what? What is 2-bromobutane? So it is a secondary alkane. Is a secondary alkane. Secondary alkane means it can undergo both SN1 and SN2. But it says aqueous. Aqueous means polar. And polar means it has to be SN1 only, sir. SN2 it will not. And if it is SN1, we get racemic mixture. What is racemic? Sir, equal amount of dextro and levodopa. So what should be the option? Sir, plus or minus butane. Next one. What will be the option? So you know that one. Whenever you react with Grignard reagent, a magnesium, you get RMGX. That is Grignard reagent. When RMGX undergoes hydrolysis, what you get? You get RH, hydrocarbon you get. That means in this case, which is R? Benzene is the R. So you end up getting not benzene, cyclohexane is the ring. So you get cyclohexane back. Next one. Reactivity order of halides for dehydrogenation is I told you where it is easy to break, Ri is easy to break. I told you Ri it is easy to break. So Ri should come first. That means B or C. What may be the option? Sir, after Ri, RBR will come. So option is next one. Which of the following statement is true in case of alkyl halide? Alkylates do not undergo addition reaction. They go substitution reaction. So option D. What may be the option? So they're polar in nature. Yes, they're having a plus or minus. This is minus and plus. So they can form hydrogen bond. Wrong, sir. They're soluble in water. Insoluble in water. They undergo addition reaction. Wrong, sir. They undergo addition reaction. They undergo substitution reaction. So these are all incorrect. He's asking true. True means only options. Tertiary alkylate is practically inert to substitution by SN2 mechanism. Why? What is tertiary alkylate? So imagine I'll get tertiary butyl chloride. Tertiary means it will be like this. Say this is the carbocation. You're having a nucleophile. Nucleophile will not attack it by a center mechanism. Why? So these are bulky groups. CH3 are bulky. When they have a bulky group, the nucleophile cannot approach it. There will be a steric hindrance. Due to repulsion of electron cloud, it has to be cell D. Which of the following halide undergo hydrolysis on warming with water and aqueous NaOH? Already told you. Means this chlorine is to be replaced by OH. So which is better is asking. I told you electron withdrawing group will favor NSR, nucleophilic substitution reactions. Which is a withdrawing group? This NO2 is withdrawing group. And where NO2 is more? In a T cell. So D is the answer. The compound having longest CCl bond is, what may be the option? Wherever double bond is there, there will be a short bond due to partial double bond character. So here also double bond is there, so partial double bond character. Here also double bond is there, partial double bond. So option should be B, sir. Is the answer. Next one. Which of the following halide shows highest reactivity towards SN1 reaction, sir? What may be the option? If you look at this one, this is a primary. So primary will go for SN2, sir. So this is also primary. They go for SN2. And what is this? This is a chlorobenzene. So no reaction only. Because chlorine is directly attached to benzene ring. So what may be the option? So last one is remaining then. What is that one? So last one is we call it as a benzylic halide. Yes, that is more stable due to benzene ring. So this becomes a carbocation and stable due to benzene ring. So we call it as what? Benzylic halides. And benzylic halides are more reactive. So prolonged exposure of chloroform in humans may cause damage to the liver. Why? Already we have discussed, due to exposure to COCl2, poisonous gas. The correct IUPAC name of the given compound is? What will be the correct IUPAC name? So the compound is like this. This is a benzene. You have a NO2. You have a F. And there's a one line here. That means what? It is nothing but ethyl group. The ethyl group. What may be the answer? How to name this compound? Very simple. The adjacent group should be given a preference. Sir, adjacent group should be preferred. Which is the adjacent group? Sir, F1 and NO2. So 1, 2, 3, 4, 5, 6 it is, sir. But while writing the substituents, you have to use a alphabetical order. Who come first? Ethyl come first. Where it is present? 4-ethyl dash. Then comes fluorine. So 1-fluoro dash 2-nitro. 2-nitro dash. Which is the option then? So 4-ethyl is the option. So A is the option. So some of the question, let us take it from what? This is from 2021. I will take last year. 2022 I will take. In following pairs of halogen compound, which compound undergoes fastest SN1 reaction, sir? Very simple. SN1 means I told you. Here the intermediate is carbocation. And which carbocation is more stable? Tertiary, secondary, primary. So look for tertiary. That's it. Nothing else. Let us see one by one. So this is a tertiary. Imagine you are removing chlorine. This is a, sir, attached to 2 carbon. So it's a secondary. Next we'll go. Here this one, sir. So this is a only 1 carbon is there. So this is a primary. So primary, sir. Here this carbon is attached to, sir, 2 carbons. So this will be secondary. Primary will not prefer it. So this cannot be. I just remove it. So he has given this pair. In A, this is a secondary. So this is primary. B, let us see. So this is tertiary. And this is primary again. So here, this is secondary. And this is, sir, attached to 2 carbon here. So it is also secondary. So this is tertiary. Imagine you are removing chlorine. Here, this is secondary. Secondary. So wherever the primary is there, so that option cannot be. Sir, A and B cannot be. Either C and D. In C, both are secondary. So that is also not possible. Option is this. Now let us go to, okay, one more question I will take up from 2022. After this, we'll go to coordination compounds. So what is this molecule? Undergoes solvolysis. Solvolysis means with water. Means nucleophilic substitution reaction. That means you get carbocation. Again, depends on stability of carbocation. Imagine you are removing the chlorine. This becomes a carbocation. Is attached to 1 more carbon, so it is a primary. And imagine you are removing chlorine. This also becomes a carbocation. This also becomes carbocation. This also becomes carbocation. If you remove chlorine. But here is a benzene is there, having double bond. Carbocation having double bond is unstable, so don't leave it. So it is also having double bond. Leave it. So only option A and B. But I already told you, in carbocation, electron donating group stabilizes benzene, this one, carbocation. Or more benzene, more stability. I told you. more benzene, more stability. What is the option then? Sir, which is attached to benzene? Carbocation attached to benzene. So this one, A. A is more stable, sir. That is more easily undergoes solvolysis. Let us go to coordination compounds. So what are the things we have to study in coordination compound? First, the definition itself we should know. The addition compound can be of two types, double salt and coordination compounds. What is a double salt? Which retains its identity only in a solid but not in solution. Double salt retain identity. So only in solid, not in solution. Not in solution. We call it a double salt. What is a complex? So the retain identity. Really, both in solid as well as solution. And that complex compounds are called as coordination compounds. Because when you put it in water, the complex ion will remain as it is. They will not separate. Whereas in double salt, all the components, they get separated into individual ions. They lost their identity. So why we call it as coordination? Because if you take a potassium ferrocyanide as a coordination compound in this addition compound, here iron is surrounded by what? Cyanide. And all these cyanide will form what? So this cyanide forms a coordination bond with iron. So they form a coordination bond with iron. And that's why we call it as what? Coordination complex. What is a coordination bond? Sir, where both the electron for the bonding is given by one of the entity. And that entity we call it as a ligand. Ligand. What is a ligand? A ligand is a Lewis base. Base. There are many types of them. Monodentate, they give one pair of electron. Bidentate, two pair, like oxalate, ethylene diamine. Hexadentate, EDTA, gives 6 pair of electron. Ambidentate, they have more than one donor atom, but always forms a linkage through any one of them. Either through oxygen, either through nitrogen. Like that cyanide, either they can form a bond with carbon or nitrogen. Next we take as IUPAC nomenclature. So while giving IUPAC nomenclature, always remember the cation name should be named first. So first we have to take cation, and then we have to take anion. So in this one, chlorine is having negative charge and the complex ion will have positive. And in this positive ion, first we have to take ligand, which is the ligand ammonia and water. Ammonia is nothing but what? Triamine. And water means how many? 3 molecules are there. So we call it as aqua, triaqua. And the centrometer atom is chromium. Chromium, chloride. Next, we'll take one more example. So potassium ferrocyanide. Potassium ferrocyanide. First, what we have to do, we have to identify which is cation, which is anion. So K plus is a positive ion and the complex is a negative. So who has to come first? Cation. That means potassium. Yes, a potassium. And then this is the complex. In this cyanide is the ligand. How many? 6. Hexa, cyano, iron is. And when iron is present in a negative ion, we have to give it a Greek name. Correct. And what is the oxidation number of iron? So 2, sir. Okay, right. Then there are very important three theories. So which are these three theories? One is Werner theory. What is this Werner theory says? According to this theory, if we take any compound, like say, let us take potassium ferrocyanide, which one? K4FeCl6. So in that, the iron is the center metal atom. And cyanide is the ligands. And the K plus ion is the counter ion. Here, the center metal atom, which is the center metal atom, iron. He says always it has a two valency. One is primary, another is secondary valency. And he says primary valency is variable. What is primary valency, sir? Is nothing but charge on it. What is primary valency? Is nothing but charge on it. And it is variable. And it is satisfied by, sir, negative ion. Remember this point. Whereas secondary valency is satisfied by negative ion or neutron molecule. Whereas, sir, secondary valency can be satisfied by negative or neutron molecule. And the distribution of the secondary valency will decide the shape. So distribution of secondary valency around center metal atom will decide the shape. But it cannot explain the complex forming property. And it will not explain directional characteristics of bond. Cannot discuss about magnetic and optical property. So these are the demerits of this particular theory. What is the one more theory? Next important one. Sir, valence band theory. I think I missed it. Okay. Somewhere I missed it. Okay, Christopher theory I've taken. Okay. Okay, I missed it, but I'll tell you here. So what are theory we have to expect? Now I'll go to valence band theory. So what is this valence band theory? I'll just take a board and explain to you. I'll take the one white chalk piece. So what is a valence band theory? Valence band theory. According to this theory, every center metal atom has a vacant orbital. And these vacant orbital undergoes hybridization to form hybrid orbitals. Hybrid orbital. This is very important. So, metal is having hybrid orbital. The second point, the ligand will have, so they have a filled orbitals. Means they are having electrons. Third point, according to this theory, these hybrid orbitals of what? Of center metal atom combines with the filled orbitals of ligand. Orbital of ligand to form, he says, coordination bond. They overlap to form coordination bond. So the hybridization, what hybridization here? Already told you now, this I will take here, another color, this one. This hybridization will decide the shape. If it is sp3, it's a tetrahedral. If it is dsp2, it's a square planar. All those things are decided by what? Hybridization. Then, next point. If you are using n-1 d orbital, then you form a inner complex. Means low spin complex we call this. 3n-1d means nothing but 3d orbitals. If you are using nd orbitals, then you form an outer complex. What is outer complex? High spin complex. In bracket, it there 4d, sir. Last one. If unpaired electrons are there, sir, they are paramagnetic. And if there is a paired electron, it is a diamagnetic, sir. So this is all about what? Sir, valence bond theory. So remember, center metal atom is having, please remember, is having vacant orbital. They undergo hybridization to form hybrid orbital. And ligands are having fluid orbital. So they will overlap to form coordination bond. The hybridization will tell you the shape. So this is what happens. If it is a D to sp3 or sp3 D2 hybridization, so if it is D to sp3, sp2 hybridization, look at here. You may get inner or outer. Outer means what? If it is sp3 D2, it is outer. If it is D to sp3, it is inner. So here, iron cyanide, cobalt ammonium complex, chromium ammonium complex, these are all inner orbital complex. COF6, cupromonium complex, these are all high spin complex or outer orbital complex. They are using n-1 d orbital, means they are using 3d. These are using nd orbital, that means they are using 4d orbital. Okay. Like that, sir, if it is a DSP2, I told you, it is a square planar, like nickel cyanide or cupromonium complex. If it is sp3 hybridization, sir, it is a tetrahedral complex, like zinc ammonium and nickel cobalt, carbonyl complex. So let us come to isomerism. So what is isomerism? There are two types in isomerism. So you have both stereoisomerism as well as structural isomerism. Both you are having, sir, here. So what is structural isomerism? First, let us take ionization suppose. What is that? They provide different ion in their aqueous solution. When you put into water, look at here. Both are having the same molecular formula, but when you put into water, you get a sulfate ion as a counter ion, Br minus as a counter ion. They are called as what? Sir, ionization isomerism. So what is hydrate isomerism? If you look at the hydrate isomerism, what is happening here? Look at this ligand. Here there are 6 water ligand, 5 water ligand, 4 water ligand. So what is happening? They are all having same molecular formula. They differ in number of water molecules as a ligand. They differ in number of water molecules as a ligand. So what is the linkage isomers? These isomerism arises when you're having an ambident linkage. Next we'll go. Coordination isomers. Here it arises due to interchange of ligand between cationic and anionic complex. So this is very important. Stereoisomers. In stereoisomers, there are two types. Sorry, in stereoisomers, there are two types. Geometrical. So what is geometrical isomers? They are also called as cis-trans isomers. So they are also called as cis-trans isomers. And who will give? Anybody with coordination number 4 and 6. And they differ in spatial arrangement of metal ligand bonds. So if it is coordination is 4, you get square planar also, you get tetrahedral also. But tetrahedral complexes do not exhibit geometrical isomerism. Only square plane complexes will. You may get cis also, trans also. And here, if you look at this one, the NH3 group is present on same side, cis, and NH3 group is present on opposite, we call it trans. And this geometrical isomerism can be given by coordination with 4 also and coordination with 6 also. Both can give. Coordination number 6 means it is octahedral complex. What type they give? MA to B4 type, MA3 B3 type, they will give geometrical isomerism. But MA6 type, MA5 B type, they do not exhibit geometrical isomerism. What is MA6 type? Means same type of ligand is there. 6 ligand is there. MA5 means there are 5 types of same ligand. They will not give. They will not give. Remember this part. Where A, B, C, D represents ligands. Remember, they represent ligands. Optical isomerism. And optical isomerism is given by coordination number 6. Means octahedral complex. Of what type? MA to B to C2 type, MA B to C2 type, MA3 type, MA to B2 type. What is AA, sir? AA refers to bidentate ligand. Bidentate. And remember, it is not found in tetrahedral and square planar. That means coordination number 4. No. It is found only in what? Octahedral, that is coordination number 6. And the mirror image of each other, which is not superimposable, are called as what? Enantiomers. And why they show optical activity? Because of chiral. What is that? They have a chirality. What is chirality? Non-superimposable mirror image. We call it as chirality. Crystal field theory, last. So what is a crystal field theory? So it's nothing but a electrostatic model, we call it as. Here you try to explain the coordination bound by electrostatic model, where you take it all ligand as a point charge. According to him, the 5 d orbitals are having same energy, where in central metal atom. When ligand approaches, it splits into 2 levels, that is T2G and EG. Say for example, in octahedral complex, first we'll take the lower level is called as T2G and the upper level is called as G. In that 5, 2 will come to EG and 3 d orbitals will come to T2G. Whereas in tetrahedral complex is opposite. The EG, T2G will come to top, EG will come down. The difference between these two energy levels is called as delta T. And here in octahedral, the difference between the two energy levels is called as delta O. And based on the ability of a ligand to split this d orbital, they can be arranged in a based on their field strength, we call it as. So that is called a spectrochemical series, very important. Who is very strong? CO. Halogens are very weak. Remember, among the halogen, very weak is iodine. Who is very strong? Fluorine is very strong. So who is first among all of them very strong? Carbonate. Then comes cyanide. Then comes nitrate. EN, ethylene diamine. When the pairing will take place, when the delta O is more than P, then only pairing will take place. That means they give us low spin complex. If delta O is less than P, then complex is high spin. So, Bhagaji sir, we'll stop here and again
Sir,
continue by.
actually, another 5 minutes are there. 5:50
Okay.
there will be a break.
I can continue now then.
Another 5 minutes you can continue. 5:50 we will leave for break, sir.
Yeah, right.
Okay.
So, in which of the following complex ion, central metal ion is in a state of sp3d2 hybridization? So, in which of the following there is a central metal atom is in a sp3d2 hybridization? Yeah, give me answer, all of you. You have to give me, all of you should give me answer. I'll give you a clue. Let us take cobalt complex first. In cobalt, what is the atomic number? Sir, atomic number is 27. So in a cobalt, the atomic number is what? 27. What is the configuration? Sir, argon will be 18. So let us write it as 4s2 then it becomes 3d7. But here in option A, the cobalt is in oxidation state of 3+. That means it has lost 3 electrons. So let us write 27 minus 3. So it becomes 24. Then what is the configuration? Sir, argon 4s0. You have to remove 3 electrons. And 3d6. Let us write the orbital diagram. Orbital diagram. What is the orbital diagram? Let us write 3D. One D will be having how many houses? 5 houses. E says 6. Then you are having 4s. Then you are having 4p. Since F is a weak ligand, there is no pairing. So each orbital gets single electron. So no pairing. And then 6 here. So, but here the cobalt has to combine with how many ligands? 6F. That means it requires 6 vacant orbital. And where to get a vacant orbital? I don't have. Vacant is only 4s, 4p. 4 I got. And it's 6. Because ligands are 6. Then there is no other way for me. I will go for 4d. 1, 2, 3, 4, 5. So I will use 2 vacant orbital from there. Totally I got 6. Then I can form what hybridization? sp3d2 hybridization. And by this I get 6 hybrid orbitals. If I've taken 3D, then it could have become D2sp3. But in 3D, there is no vacant orbital, so D2sp3 is not possible. sp3d2, that means option A, sir.
Sir, we'll break. Sir.
Yeah, right. Thank you.
Dear students, 15 minutes, there will be a break. Come back exactly at 6:05. The chemistry class will continue after 6:05.
So I will not disconnect it. Let it be like that only, no?
No problem. I'll run a video in between. No problem, sir. I think I'll be able to run. Your screen will go later. You can reshare it, sir.
At Daya Sagar University's Harrohaldi campus, the College of Physiotherapy is dedicated to providing students with a top-notch education in the field. The curriculum is designed to give students a comprehensive understanding of the human body and its functions, along with experiential training in the latest physiotherapy techniques. What sets our department apart is our ultra-modern facilities, including sophisticated classrooms and clinical training rooms. Our students have access to the latest technology and equipment, allowing them to hone their skills and knowledge to the highest degree. The faculty at the College of Physiotherapy is comprised of experienced professionals who are dedicated to their students' success. With our modern amenities and a supportive community, Daya Sagar University's College of Physiotherapy is the ideal place for aspiring physiotherapists to begin their journey. Nestled within the beautiful and peaceful setting of Daya Sagar University's Harrohaldi campus is the prestigious College of Nursing, where you embark on a transformative journey as we flawlessly fuse academic expertise with practical skills through our advanced curriculum. Renowned for our focus on innovation and advancement, our experienced faculty members are at the forefront of the nursing field, constantly incorporating the latest advancements in technology and research into the curriculum. Our pioneering facilities, including simulation labs and clinical training rooms, provide an immersive, real-world healthcare environment. The Harrohaldi campus is a modern and supportive community, complete with all necessary amenities, and provides the perfect, serene environment for students to focus on their studies and achieve their goals. Join our vibrant community and prepare for a successful career in nursing. Welcome to the School of Engineering at Daya Sagar University, main campus, Harrohaldi, Kanakpura Road, Bangalore. A place that values research, innovation, and creativity. Our industry-aligned curriculum offers a blend of theoretical knowledge, practical experience, academic projects, and internships for a rewarding career in engineering. With an interdisciplinary approach, you can explore your interests by selecting open electives. The on-campus innovation labs, led by professors of practice, provide immersive learning and expertise to find the best solutions to real industry problems and give a different dimension to the students' mini and major academic projects. Our Center for Entrepreneurship supports startup opportunities and provides a perfect platform to launch your next big idea into successful ventures. We also prepare you for advanced studies in the latest futuristic technologies. Our BTech programs offer the perfect combination of academic rigor and functional experience in this ever-evolving technological landscape of the future. Experience a whole new world of academic excellence in a global environment. Daya Sagar University. Live the dream.
Dear students, join back. Ask your friends to join back. Now class will start in within 1 minute. It is 6:04 now. In another minute's time, very important topics are getting continued. Ask your friends to join back. Don't miss important topics. Hope you all are preparing very seriously for CET exam. I wish you should do good. First NEET exam is there. I wish you should do good with NEET exam. Later CET exam also. Prepare well, very seriously. Ravi Shankar sir. Ravi Shankar sir. Just 1 minute, he must be getting refreshed. Sir will be back. Join back fast, students. Ask everyone to join back fast. Sir, are you there, sir?
Sir, shall I start?
Yes, sir. Over to you, sir. Thank you.
Yeah, dear students, we'll start then. So next question. Which of the following can participate in a linkage isomerism? Give me answer. All of you. Very easy, Sushmita. Very good, you got it. Then Sneha. Oh, good, good. So how to do it? Whenever we say linkage, we have to take ambient intent again. Sir, we have to take ambient intent again. What is ambient intent? Having two domains. But always uses one of it. Uses one of it. Which is that ambient intent? Yes, ambient intent, sir. The number of unit intent ligands in the complex ion is called as. So what will be the answer? The number of unit intent ligand in the complex ion is called as. So we have to know that every central metal atom is having a two valency, primary valency and secondary valency. What is secondary valency? Every central metal atom has two valency. One is primary valency, another is secondary valency. And the secondary valency is known as what? Sir, coordination number. Coordination number. What is coordination number? So the number of bonds, number of coordination bonds. For example, around the iron, say there are 6 coordination bonds. Then the coordination number is 6. So it has to be C, sir. Option C. Next one. IUPAC name of a given compound is. What compound it is? So it is a cobalt complex. So it is a cobalt complex. I told you, while giving IUPAC name, first you have to take cation and then you have to take anion. Then you have to take anion. So which is the cation here? The sodium is a cation here and the complex becomes negative. So which is the cation first? Sodium is the cation. First you have to take sodium name. Yes, sir. Everywhere sodium only. Then in anion, you are having a ligand. NO2 is there. That means nitrito. How many are there? 6 are there. Hexanitrito. And cobalt is present in a negative ion. That means we cannot take it as a cobalt. We have to take it as a cobaltate. Hexanitrito cobaltate means there are two options for it. But here the cobalt is having an oxidation number means charge on it is +3. Then it has option C, sir. C. Let us check it out. Is it right? Yes, sir. Option C. Next one. Which complex cannot ionize in solution? Sir, which complex cannot ionize in solution? In all these things now, one which is inside the bracket, we call it as a coordination sphere. Coordination sphere. And one which is outside is called as outer ion or counter ion. Counter ion. And everywhere you are having a counter ion. This can become ion. So all this then can become a separate ion. The one which is in the bracket becomes a complex ion. One which in the bracket becomes a complex ion. So option A is the answer. So that cannot ionize. Next one. A octahedral complex is formed when hybrid habitats of the following types are formed. What may be the option? You get octahedral complex. sp3 means tetrahedral. dsp2 means square planar. So if it is d2sp3 or sp3d2, both will give, sir, octahedral complex. Both will give octahedral. So it has to be option A, sir. Option A. Let's check it out. Yes, sir. Option A. A complex compound in which oxidation number of a metal is a 0. So where the metal atom is having a 0 oxidation number. Where it will be 0, sir? Let us take B. We don't know. Let us take B. What is B? Let us find out the oxidation number of platinum. Ammonia is how many? 4 is there. And the oxidation number of ammonia is taken as 0. Plus Cl2 is there. How many Cl? 2. 2 means -1 is equal to the total oxidation number of a molecule is 0. So platinum, the -2 plus 4, the -2 is there. Platinum -2 is equal to 0, or platinum is equal to how much? Sir, +2. It is +2. That means this cannot be 0, this cannot be 0, this cannot be 0. Only A is the option, sir. Why? CO oxidation number, carbonyl is 0. 0. Let us check it out. Is it A? Yes, sir. A is the answer. A ligand can also be regarded as What is a ligand? For a explain acid-base theory, there are two theories. One is Laurie-Bronsted theory, we call it as. What is Laurie-Bronsted theory? It's a proton theory. It's a proton theory. What is Lewis theory? Is a electron theory. According to this theory, anybody who gives electron is a Lewis base, and anybody who accepts electron is a Lewis acid. Is a Lewis acid. And ligand always gives electron. They give electron. So it has to be Lewis base or it has to be Lewis base. Here should be the answer. Let's just check it out. Yes, sir. Here is the answer. IUPAC name of a given compound is, what may be the IUPAC name? First, what we have to take? We have to take a ligand. Which is the ligand? Ammonia and nitrito. So in this, we'll come first ammonia. How many ammonia is there? 5. Ammonia means amines. So it's a pentaamine. Then nitrito and cobalt is there. What is the oxidation number? I told you 3. 3. So what is the option? Sir, option is sir. IUPAC name of given compound is, I told you, whenever you take IUPAC, first you take cation. Then you take anion. So which is the cation here? K plus is a cation and the complex ion becomes negative. So the name first should start with potassium. Everything is potassium. Then in this complex ion, the first should come ligand. What is ligand? Cyanide. How many are there? 4. Tetracyano. Nickel is also present in negative ligand. Should be nickelate. Tetracyanonickelate. Tetracyanonickelate. Means slightly these two options can be answered. So this cannot be option. This nickel name should not come. It should be nickelate. And it should be tetracyano. It's not cyanato. So option is A. Which one of the following is wrongly matched? Which one of the following is wrongly matched? What may be the option? What could be the option? Sir, cupromonium complex is a square planar. Like say, for example, cupromonium sulfate, CuNH3,4SO4. Like this compound. Can be square planar? Yes, sir, it can be square planar. What hybridization it is? DSP hybridization. So it is right. He's asking wrong. Nickel carbonyl. Yes, sir. CO is a neutral ligand. Yes, sir, right. And iron cyanide complex is a sp3d2 hybridization. Sir, is it possible? That we don't know. That we have to find out. Sir, cobalt ethylene diamine complex follows En. What is En? Effective atomic number. So it has to be C. It has to be C, sir. So what is the atomic number of iron? Then if you write the electronic configuration, you can make it out. So what is iron? So iron is equal to, atomic number is equal to 26. Write the configuration. What is the configuration? Argon, sir, 4s2, 3d6. So 3d6. If that is the thing, why it has to be sp3d2? Why not it is d2sp3? So it can be d2sp3 also. If you write it, you can understand. Can you tell me, anybody? What is the option? What is the reason? Very good. What is the reason? Let us understand why I have taken it as a wrong. So if it is 3d6 and here cyanide is a strong ligand, remember. Strong ligand means what? Delta O is more than P. Means what, sir? Means pairing take place. Where? In 3d orbital. What is 3d orbital? There are 5 d orbitals are there. 1, 2, 3, 4, 5. Pairing will take place. What is pairing? 1, 2, 3, 4. How many are having? And here iron is present in what state? 3 plus state. 3 plus means you have to write it for 26 minus 3. So 23 out, right? 23 means it is 3d5. So it is 3d5. 3d5 means only one electron is left behind. This is 3d. And you'll be having 4s next to it. You'll be having 4p next to it. 4p means there are 3 orbitals out there. And you have to combine. Iron has to combine with how many ligands? He has to combine with 6 ligands, 6 cyanide. So you need empty houses. How many empty? He needs 6 empty houses. Let us check it out. 1, 2, 3, 4, 5. Yes, are available. These vacant orbital undergo hybridization. D2sp3. D2sp3. So it is not sp3d2, sir. It is d2sp3. So this is wrong. This is wrong. The APS name of the given compound is, again I told you APS name. Just remember, first one is cation. So then comes anion. What is a cation here? The chlorine is negative and the complex becomes cation. So in the cation, which are the ligands? Ammonia and chlorine. So how many ammonia is there? Sir, 4 ammonia is there. Ammonia means amine. Amine. Chlorine means, we can call it as chlorido or chloro. So how many chlorine? 2 chlorine. How many ammonia? 4 ammonia. There should be tetramine. So all these things are there. Tetramine. So dichloro. Everywhere dichloro. Cobalt chloride. Everywhere is, everything is same. All three are same almost. But the difference is oxidation number. And here cobalt is having oxidation number of how many? So 3. So how can you say 3? Let us calculate. Cobalt we want. Ammonia is 0 into 4 plus chlorine. How many are there? So 3 are there into minus 1 is equal to 0. So it becomes CO minus 3 is equal to 0. And then cobalt is having what charge? Plus 3. That itself is the oxidation number. So option should be B, sir. Option should be B. Next one. Which of the following is a negatively charged bidentate ligand? Negatively charged bidentate ligand. Sir, cyno. Cyno is a monodentate. So B cannot be. Ethylene diamine. What is ethylene diamine? NH2, CH2, CH2. That means it is also not negatively charged. So this cannot be option. Acetate CH3CO minus monodentate. So he's asking negatively charged bidentate. Option should be yes. Option is A. Next one. The secondary valency of platinum in tetramine dichloroplatinum is how much it is? What will be the option? Very simple. Secondary valency is nothing but, already I told you, is nothing but coordination number. What is coordination number? Number of bonds. That's it. So number of bonds. If it is a monodentate ligand is there, it is nothing but number of monodentate ligand. Monodentate ligand. So what may be the option? Let us see how many ligands are there. Sir, dichloro. It is a platinum complex. So dichloro, there are 2 ligands here. Amines, how many? 4 is there. 4 plus 2, sir, 6. Then your coordination number is 6. Secondary valence is 6. Next one. The atomic number of cobalt is 27. The EN of cobalt in sodium cobalt complex is, EN means I told you effective atomic number. We call it as EN is equal to Z minus X plus Y. X plus Y. So what is Z? The atomic number of the given centimeter atom, cobalt. 27. So what is X? X is the number of electron lost during the process. Y is the number of electron given by the ligands. We call it as. So what is the option? So 36C is the answer. A group of atoms can function as a ligand when it should have a pair of electrons. That means we should donate it. Yavaga, when it is having a unshared pair of electrons. A correct statement about the complex is. What is the correct statement? What may be the option? First, we'll remove unwanted things. Which we can remove? One by one, we'll start. Cobalt already I told you. What is the oxidation number of cobalt? 27. Means how to write configuration? Argon 4s2 3d7. Is it not? But here cobalt is in 2 plus state. 2 plus means remove 2 electron. So you get 25. Now it becomes argon 4s0 3d7. And which is the ligand? Ammonia is the ligand. Ammonia is a strong ligand. Strong ligand means, sir, delta O is more than P. Means, sir, pairing take place. So if you write the diagram now, orbital diagram for it, what is this one? Let's write it for 3D. 3D7, you got it? No. How many orbitals are there? Sir, 5 are there. 3D. And we have to pair it. 1, 2, 3, 4, 5, 6. Sir, 7. Then he says, so this is the one. So there's an unpaired atom. Unpaired atom means what? Sir, it is a paramagnetic. Unpaired means paramagnetic. So paramagnetic. So he says it's paramagnetic only. So it is right only. Then what is the next one? Like that we have to.
Hello. Hello. Ravi Shankar, sir. Just 1 minute, students. Sir will be back.
Yeah, I got it. Just a minute.
Okay.
Yeah. So what is the option? So it can be A also and B also. A also, B also. So what may be the option? Sir, A can be A answer, but C and D is definitely wrong. Okay. Sometimes you may get an option like this, then they'll give a grace marks. This is from 2014 when they got grace marks. So option is both A and B. In which one of the pairs of the ion given, there is an ion that forms a coordination compound with both aqueous sodium hydroxide and ammonia, and other ion that forms a coordination compound only with aqueous sodium hydroxide? What may be the option? You should form coordination.
Any issue, sir? Student, just wait. Sir will be back. Any issue you are facing, sir? Student, just 1 minute. Student, sir is joining back. Hello.
No. I think I can show. But when we'll start now. No problem. That's why I told you today is a problem. Okay. Yeah. Bhagiji sir, is it audible? All of you?
Sir, it is audible and visible.
Very good. So, what is the ion there? Sir, zinc can form both complex also. It can react with sodium hydroxide to form zinc hydroxide, as well as it can react with ammonia to form a complex also. Whereas aluminum can react only with NaOH. So what may be the option? So is it zinc aluminum or is it a zinc copper? So it is a zinc and aluminum. So aluminum reacts only with NaOH. It forms aluminum hydroxide or sodium aluminate. Whereas zinc can form both hydroxide as well as a complex also. Next one. The complex ion having a minimum magnitude of delta O is. So how to calculate this one? This is based on spectrochemical series. I told a spectrochemical series. What is spectrochemical series? Where ligands are arranged based on their ability to split the d orbital. So I told you already, we have to look at these particular ligands: chlorine, water, ammonia, and cyanide. He says minimum magnitude of delta O. Complex and having minimum magnitude of delta O. So which is the weakest ligand in this? I told you halogens are weakest. Where is the halogen is present? Sir, in a D it is present. Sir, that is the last one. Next one. Which of the following will be able to show the geometrical isomerism? So which will show geometrical isomerism? Already I told you very clearly, tetrahedral will not show geometrical isomerism. So tetrahedral means, sir, both A and B is not possible. Leave it. So only it has to be square planar. Means in the coordination number, in the complex having coordination number of 4, so tetrahedral will not give no geometrical isomerism. Only square planar will give. But what kind of square planar? Say imagine metal is the M is the metal. You need to have a ligand of what type? MABCD type. That means, sir, option D, sir, last option it has to be. Next one. Sir, how many ions per molecule are produced in the solution when more salt is dissolved in excess of water? What is the more salt? Ammonium ferrous sulfate or ferrous ammonium sulfate. You can call it in both ways. When ferrous ammonium sulfate is dissolved in water, how many ions you get per molecule? That you have to write. Let us take ammonium ferrous sulfate. Means you have to write it like this. Sir, FeSO4. Full stop. Ammonium sulfate. NH4 twice, sir. SO4. Ammonium sulfate. Full stop. 6H2O. So when you put it in water, the iron becomes iron ion. Fe2 plus. And sir, ammonia becomes 2NH4 plus. Sulfate ion, how many are there? So there are 2 sulfate ion. SO4 2 minus. So totally how many ions, sir? Totally there are 5 ions. 5 means, sir, it has to be option A. Option A is the answer, sir. The number of isomers possible for the octahedral complex is. Sir, how many isomers are possible for an octahedral complex? What is octahedral? Coordination number is 6. Coordination number is 6. Coordination number 6 means it can give you both geometrical as well as optical isomers. So what may be the possibility? Let us check it out. Sir, how it is possible? How we can write it? You are having a cobalt complex. Let us write some cobalt. Sir, you are having Cl2En, NH3 twice. What is En? En is ethylene diamine. It's a bidentate ligand, sir. It's a bidentate ligand. So you may get it like this. Cl, Cl. So you get En, ethylene diamine. It can satisfy the work of 2 ligands. So you are having 2 more ligands. What is this? NH3, NH3. This is what? Transferum. What is cisferum? You write chlorine on both the sides. We call it as what? Cisferum. Then you get NH3, NH3, and you have 2 more ligands. But 2 ligands are satisfied by ethylene diamine. This is a transfer. This is a cisferum. So you got cis and trans. That means you got 2 isomers already. Then what is the third isomer, sir? What is the third isomer? We got 1 trans, we got 1 cis. What may be the third isomer? How to write it? That is optical isomer. What I told you, cis and trans is geometrical isomers. Can I get optical? Yes, you can get optical. How you get optical? You should show chirality. What is chirality? Non-superimposable mirror image. You need to have a non-superimposable mirror image. Or mirror image. Image. Means you are having a cobalt. I will take Cl and NH3. I will take. So I will take En, ethylene diamine. I will take 1 Cl and 1 NH3. If I take a mirror image of it, if I take a mirror image, let us see. It should not be non-superimposable. CO, Cl, NH3, NH3, Cl, ethylene diamine. Yes, sir. This is not superimposable. It's a mirror image, but not superimposable. So here geometrical isomers you got 2, and here you got 2. Totally 4, sir. D is the option. Next one. CO is a stronger ligand than Cl minus. What will be the option? CO is a stronger ligand than chlorine. What will be the option? There is a small tilt to it, small twist into it. What is that? When metal binds with chlorine, it's a normal coordination bond. It's a normal coordination bond or coordinate covalent bond. But when metal binds with CO, it is not like this. It can form both sigma bond as well as pi bond. Because metal also gives back electron and forms a pi bond. Usually sigma bond is formed when cobalt gives electron to it. So this is a special bond. Because of this synergistic effect, we call it as. Because of this synergistic effect, this bond is very strong. So you're having pi bond. Pi bond means what is the option? Sir, option B, sir, option B. Let's check it out. Yes, sir, option B. Next, which of the following sequence is correct regarding field strength of ligand as per spectrochemical series? I told you, among all the ligand, CO is very strong. Carbonyl. CO is very strong means which has to come first means in this case, he has given arrow mark in what way he has given increasing order. That means at last you need to have CO. That means option what you're having is, so you're having both A as well as B. As well as B. What will be the option? So then comes cyanide. Then comes, sir, among halogen F minus, which is stronger. Then SCN. That means, sir, option A. Option A. As per AEP's name, the name of the complex is, already we have done this one. So what is this option? When ethylene diamine comes, we call it as chlorido bis. Bis means the first option, sir. The coordination number and the oxidation state of the element M in the complex is very simple. What we have to do is that we should know metal is the center metal atom. Who is there around him? Oxalate is there. What is oxalate? Sir, oxalate is a bidentate. Bidentate. Remember, it means you can form two coordination bond. Even E, sir, ethylene diamine. E is also bidentate. Ethylene diamine is also bidentate, sir. Bidentate. So they form how many bonds? Sir, they form 6 bonds. Say ethylene diamine forms 2 bonds. Then what he says, there are 2 En. The 2 En means they form 4 bonds. And then you're having oxalate. Oxalate also forms 2 bonds. So totally there are 6 coordination bonds. 6 coordination bond. That means secondary valency is 6. How many ligands? There are 3, sir. So 6 plus 3, it has to be. What is the option? Sir, C is the answer. According to crystal field theory, metal ligand bond in a complex is what it is. I already told you, crystal field theory is all about electrostatic model. Sir, already we discussed about it. It's an electrostatic model where ligand is taken as a point charge. Electrostatic means what? Point charge means what? Sir, it is ionic. Ionic means what? Sir, it has to be option A. Next one. So IUPAC name of a given compound is, okay, what may be the option? Many we have done already. A is the answer. So this compound shows what kind of isomerism? Very simple. So this compound is having an ambident event. What is ambident? NO2. NO2 means it can form bond through N also. It can form linkage through O also. That means that it is a linkage isomerism. Linkage isomerism, sir. That is option A, sir. Okay. Question number 30. Yes, sir. Option A. 31. Addition of excess silver nitrate into an aqueous solution of 1 mole of palladium chloride and ammonium complex gives 2 moles of AgCl. The conductivity of this solution corresponds to what? He says. Very simple. He says it forms 2 moles of AgCl. 2 moles of AgCl. That means 2 Cl minus should combine with Ag. And 2 Cl minus means it should come from complex. Provided it is a counterand, then only it can come. Otherwise, it cannot participate in this reaction. That means your complex should be PdNH3 twice. How many is given? 4NH3 is given. So 4NH3, that counterand should be outside. Generally, when you add AgNO3 to it, the 2Cl will combine with Ag to form 2 moles of AgCl. Otherwise, it is not possible. Otherwise, it is not possible. That means, what should be the ratio? Complex ion is 1 ratio and chlorine is 2 ratio. 1:2, sir. 1:2 means option C, sir. Next one. The formula of a penta aqua nitrato chromium complex is. The complex is what? Center metal atom is chromium. Chromium means we have tried Cr. Penta aqua means water. How many? Sir, 5. He says nitrato. That means, sir, NO2. NO2. Then what happens? Penta aqua nitrato chromium nitrate. Chromium nitrate, he says. Nitrate means, sir, NO3 should be outside. NO3 should be outside. How many? 2 should be outside. 2 should be outside. So this complex means option C, sir. Next one. Sir, which among the following is the strongest ligand? I told you among all the ligand, the strongest is CO, carbonyl. Then cyanide should come. Then cyanide should come. So option is C, sir. The coordination number of iron and cobalt in the complex is respectively. What is the coordination number? Already discussed. It is the number of bonds. What is the coordination number? Very simple. It's the number of coordination bond. Number of coordination bond. It is not the number of ligand. Number of ligand. In the first complex, if you see, oxalate ends are there. How many oxalate? Right. Oxalate. How many are there? Three. Three oxalate is there. Each oxalate is a bidentate. Means they can form 6 bonds. They can form 6 bonds. So that means coordination number is 6. One thing. Then in second complex, if you observe it, how many ligands are there? SCN4 it says. 4 means 4 ligands. It's a monodentate. Monodentate. Monodentate means what? It can form only 4 bonds. Means coordination number is 4. Sir, 6 and 4. Means option C, sir. So number of stereoisomers exhibited by the COEN to Cl2 complex is. Already I told you. COEN to Cl2 means what? It is an octahedral complex. Octahedral means what? Sir, octahedral means coordination number is 6. They can form both geometrical isomers and optical isomers. Optical isomers. What are the geometrical isomers? Cis and trans. That means, sir, we got already 2 isomers. Cis and trans. Then what may be the options, sir? In the cis and trans, only trans will not have any mirror image. Cis can have a mirror image. Cis can have a mirror image. So I got to, in these two, cis can have a mirror image. But trans, no. So 2 plus 1. So it has to be 3 isomers. 3 isomers. Means what? Option is C, sir. Sir, how it is option C? You write it down. We can write it down. CON to Cl2. No, first you write CO at the center. You want trans? No. Trans means you write Cl at the opposite end. Then the remaining 2 ligand, you join it by ethylene diamine. So if you take a mirror image of this, it's not possible, sir. It will not give no mirror image because it is superimposable. And if it is superimposable, it cannot be isomer. So this is one structure. This is trans. What is cis? You take cobalt and put chlorine on same side. That's it, over. Then remaining 2 bonds you form with ethylene diamine. Remaining 2 bonds you form with ethylene diamine. Over. And this can give a mirror image. Cobalt, Cl, Cl, Cl. And then ethylene diamine. Then you have ethylene diamine. So there are second isomer, third isomer. So totally 3 isomers, sir. Next one. The IUPAC name of a given compound is, this already we have done. Option C. Now let us go to transitional elements. What is transition elements? So we call it as D&F block. D&F block elements. You know that in our period table, the 1 and 2 we call it as what? S block. From 3 to up to 12, we call it as D block. And 13 to 18, we call it as a P block. We know that one. And 3 and 12, we call it as a D block element or a transition element because when you go from left to right in a period table along the period, we call it as along the period. We're going to go along the period. The metallic property from the left side changes to non-metallic property. There are so many properties like this. So one more example we will give. Electropositivity slowly changes into electronegativity. So all the transition takes place at the middle of the table that is called as a D block. So we call it as a transition elements. They have a general configuration. N-1 means penultimate d orbital accepts 1 to 10, ns 0 to 2. In this, there are 4 series are there. So 3D series, 4D, 5D, 6D series. What are 3D? From scandium to zinc, yttrium to cadmium, lanthanides, hafnium to mercury, actinides, rutherfordium to copernicium. So let us take few properties of this particular D block element. Melting point and boiling point are I. Just remember why means because due to strong interatomic metallic bond. Enthalpy of atomization means to break the molecule into atom is very strong due to strong interatomic attraction and very high. Atomic and ionizers. What will happen? Sir, from left to right, what will happen? The size decreases. Why, sir? Due to increased nuclear charge and ineffective shrinking of d electron. And down the group, what will happen? So down the group, it increases. The size increases. Next we'll go. Just a minute. Ionization enthalpy. What is ionization enthalpy? Energy required to remove the electron. Please remember, sir, it increases from left to right in a series. Zinc cadmium is very high because of highly stable state. And chromium and copper also shows high value due to stable state of off-period and complete field. Next, we'll take the oxidation state. They have a variable oxidation state. Why? You can take electron from N-1d also. You can take it from Ns also. Highest oxidation states are found in fluorides and oxides, but oxides are very stable due to multiple bonds. What are the states? The compound in +2 and +3 oxidation states are mostly ionic. And highest oxidation state depends on both S as well as N-1d electron. Maximum oxidation state increases from scandium to manganese and then decreases to zinc. So electropotential. Remember this one. If you have a positive electropotential, you can act as a very good oxidizing agent. And copper as a positive E0 value means it has a low hydration enthalpy. What is negative E0 values means? They give electron easily. They give electron easily. Next one. Formation of colored ions. Just a minute, go through it. So magnetic property. Why they're magnetic? They have unpaired electrons. And how to calculate magnetic property? N into n plus 2 square root of n into n plus, where n is the number of unpaired electron. So they give a color. Color is again due to unpaired electrons. because they jump from d orbitals to another d orbital. We call it as a dd transitions. Next one. So formation of complex compound means coordination compound. Yes, they form a coordination compound due to high nuclear charge and small size. They act as a catalyst due to variable oxidation state. They form a interstitial compounds with small atoms like hydrogen, carbon, and nitrogen. Alloy. Due to similar size, they can form alloys with metals. Okay. And remember, in oxides, if you take oxides of this particular D block elements, I told you they state vary from +1 to +7. The ionic character, remember this one. So ionic character decreases, whereas the acidic character increases as oxidation state increases. Next one. Two compounds you have to understand, very important. The two compounds are potassium dichromate and potassium permanganate. Both are oxidizing agent. And you know that you can prepare it from what? Chromite ore. And these dichromates are having orange color. Whereas when you go towards acidic condition, they have a yellow color. Remember this one. In aqueous solution, dichromate and chromate ion exist with equilibrium with each other. So in an alkaline medium, the solution is yellow, whereas in acidic medium, the solution is orange color. And potassium permanganate, they're also very good oxidizing agent, like a dichromate only. They're prepared from pyrolusite. Then in preparations, you have gone through it. Next, I will take. The properties. These particular permanganate can act as a strong oxidizing agent in both alkaline and acidic. They can oxidize I- to iodine, ferrous to ferric, oxalate to carbon dioxide, like this. This shows that they're a very good oxidizing agent. Please remember it. So usually when involving volumetric titration of KNO4, we use dilute sulfuric acid, but not HCl or nitric acid. Because HCl is oxidized to chlorine, HNO3 itself is a strong oxidizing agent. When you come to F block element, you know that one, the last structure enters into F orbital. They have a general configuration of N to F1 to 4, N-1, means penultimate d orbital 0 to 1, NS2. Please remember the general electronic configuration. If you take a lanthanides, okay, you have a lanthanide contractions. You know that one oxygen state is +2 and +4, but common is +3. Remember this one. Cerium 4+, they always they act as oxidizing agent. Okay. And cerium 3+, europium 2+, ytterbium 2+ can act as a strong reducing agent. Yes, they react with the air. They form wild soft metals. They tarnished very easily. They burn in air and form oxides. They give color due to FF transition, we call it as. Magnetic property, La3+ and Lu3+ are diamagnetic, while all trivalent are paramagnetic. Coming to this particular thing, reducing nature. Since they lose electron easily, they are a very good reducing agent. Since they lose electron, they are highly electropositive. And they form alloys easily with other metals. Remember this one. Tendency to form complex? No, sir. They do not have much tendency to form complex. Why? Due to low charge density because of their large size. Lanthanide contraction. What is lanthanide contraction? Progressive decrease in the size from lanthanum to lutetium. We call it as a lanthanide contraction. Why, sir? Because the shielding effect in F orbital is very less, and increased nuclear charge is there, and the contraction takes place. So what are the consequences? The consequences is that The 4D and 5D transition series almost have the same ionic radii. Due to that, they have the same property also. And most of these lanthanides is to make mischmetals, allies of lanthanide metal with iron. Remember this one. What are the characteristics of actinides? If you take actinides, if you take the ionic radii, here also the contraction takes place. And also,
Hello, student. Just 1 minute. Sir will be back. He must be having some power backup problem. Okay.
got it?
Yeah, got it, sir.
Okay. Yeah, right. So just compare a few things with lactinides and actinides, then we'll go to questions. So what are the important things here? In lanthanides, I told you plus 3 is very common, but you have plus 2 also, plus 4 also oxygen state. Whereas in actinides, you have a variable oxygen state. Remember this one. And they're also like lanthanides, they also are a very good reducing agent. They're also electropositive in nature. And one more thing you have to remember, most of these actinides are radioactive. Remember this one, they're radioactive. But here, they are non-radioactive lanthanides. They do not form oxocations, whereas actinides form oxocations. Lanthanides are less basic, whereas actinides are more basic. And lanthanides, due to the loss size, do not form a complex, whereas they form a complex. Means coordination. Because actinide contraction is more than lanthanide contraction. Okay, remember this one. Based on this, we will take some questions. The highest magnetic moment is shown by the transition metal ion with the configuration. What may be the option? Already we have discussed. Magnetic momentum means what? So mu is equal to square root of n into n plus 2, where n is the number of unpaired electrons. Number of unpaired electrons. And where we get maximum unpaired electrons are in 3d5, where each d orbitals will be having only single electron. So n is equal to 5 here. So what will be the option then? So it has to be option B, sir. Should be. A transitional metal ion exists in highest oxidation state. It is expected to behave as a, what may be the option? What is the oxidizing agent? What is this reducing agent? First, that you have to understand. Then it becomes easy for us. So, what is the oxidizing agent? Substance which oxidize others, and undergoes reduction. We call it as a oxidizing agent. What is undergoing reduction? That means to accept electron. You have to accept electron. Then you are called as oxidizing agent. Say you are having ferrous and ferric. If you ask me, sir, who will undergo oxidation? Or who will undergo reduction? What is reduction? Accepting electron. Say, for example, Fe plus 2 accepts electron. If he accepts one electron, he can become Fe plus 3. If Fe plus 3 accepts electron, he will become Fe plus 4. So this is not possible because Fe plus 4 state is not possible. That means iron in a highest oxidation state cannot undergo reduction. Means it cannot act as a oxidizing agent. O at 3 plus cannot act as oxidizing. Means you cannot accept electron at highest oxidation state. You cannot act as an oxidizing agent. That means option C, sir. Option C. Next one. The formula mass of more salt is 392. The ion present in the oxidized by KMnO4 in acidic medium. The equivalent mass of more salt is. What is the equivalent mass of more salt? So how to find it out? Bhagiji sir, are you able to see the drawing? Bhagiji sir, are you there?
Yes, sir. I can able to see the slide, but drawing I was not able to see.
You are not able to see the drawing. All this.
Yeah, now I am able. Your marked star, no, sir.
Star, no.
Yeah.
Can you see the star on other side also?
Yes, sir.
Okay, good. That's it. Okay, no, that's what I was. So all the while I was drawing, everybody was able to see it.
No, that previous one I was able to see, but now it was clear. Now I could able to see, sir.
The previous you were able to see, no?
Yes, sir.
No. That's what I was. Okay, right. So what is this more salt? Already I told you. It's a ferrous ammonium sulfate. So what you're doing here? You're using the oxidizing agent KMnO4. So what is a more salt? Sir, more salt is a ferrous ammonium sulfate. Means ferrous sulfate. You're having plus you're having ammonium sulfate. NH4 twice SO4. Plus I told you 6H2O. This is your more salt. And you are adding KMnO4 to it. What is KMnO4? Potassium permanganate. And in more salt, what you are having? Iron. Iron is in ferrous state. Plus 2. What will happen? Your potassium permanganate will oxidize ferrous. will oxidize ferrous. And ferrous become ferric. Ferrous become ferric +3. And KMnO4 is oxidation agent. It oxidizes others, it itself undergoes reduction. When it undergoes reduction, E become Mn+2. E become Mn+2. So here, what is important to us is this one, iron. So iron from +2, it become +3, +3. How it become +3? By losing electron. By losing electron. And this electron will go to whom? It will go to K. You will accept electron, and you know that anybody who accepts electron is an oxidizing agent. Oxidizing agent. Yes, KNO4 is an oxidizing agent here. Ferrous sulfate is a reducing agent. So we are not required all those things. So we have changes from +2 to +3. So change in oxidation number is 1. Why you require all these things, sir? Because that's what I require for my calculation. You want equivalent weight? No. What is equivalent weight? Equivalent weight is equal to, in case of redox reaction, molecular weight divided by change in oxidation number. Change in oxidation. How much, sir? Change in oxidation number is 1, sir. So 392 divided by 1 is, sir, here equivalent weight is also same, 392 1 day. Option is yes, sir. Option is A. Formation of a colored solution is possible when metal ion in the compound contains. What may be the option? I told you there should be DD transition. What has to happen? So there has to be DD transition. What is DD transition? They should jump from D energy to another D energy. What is the D energy? So we know that in CFT we have discussed. There are 5 d orbital. In this 5 d orbital, they split into 2 energy level. One is T2G and another is EG. These are called as D energy level. Electron should jump from 1 D to energy level to another D. That's called as DD transition. And for that, you need to have unpaired electron. Unpaired electron. So what should be the option? It has to be B, sir. Yes, B is the answer. Which of the following forms a colorless solution in aqueous medium? Colorless solution in aqueous medium. So how to tell all these things? Colorless means there should not be any unpaired electron. Everything should be paired up. That's it, nothing else. It has to be paired up. How to do that? Let us take first one. Where we start, we'll start with titanium. Titanium 3+. But before that, titanium, what is the coordination number? What is the atomic number of titanium? Is 22, sir. 22 means what? Argon 4s2, 3d2. And you have to remove 3 electrons. That means it should become, sir, 19. Argon. You have to remove 3. If you remove 3, sir, it becomes 4s0, 3d1. Yes, sir, there is a 1 unpaired electron. You will be colored. There is a 1 unpaired electron. He can jump. He can jump from one energy level to another energy level. He is colored. So what is the question? Sir, it is all about colorless. So D is not possible. D is not the answer. Let us go to C. We see, sir, scandium 3+. First, we'll go for scandium atomic. So scandium atomic number is 21. 21 means argon 4s0 3d1. So 4s2 3d1. Sir, you say 3 plus. 3 plus means what? You remove the 3 electrons, so it becomes 18. 18 means, sir, it becomes argon 4s0 3d0. It is almost the configuration of argon only. There is no unpaired electron. So no unpaired electron. When there is no unpaired electron, there is no DD transition. So no DD. When there is no DD transition, no color. So he's asking for colorless. No, colorless means answer is option C, sir. Option C. Yes, C is the right answer. Mercury is a liquid metal because it has completely filled d orbital that prevents DD overlapping of orbitals. It has completely filled d orbital that causes DD overlapping. It has a completely filled s orbital. It has a small atomic size. What may be the option? Mercury is a metal, even though it is a liquid state, because what is happening there? Sir, DD overlapping is not allowed there. That means it is preventing it. Prevents. Where is that word? So that word is present in option A, sir. When sulfur dioxide is passed in acidified potassium dichromate, the oxidation state of sulfur is changed to what? This kind of problem we have done it in redox reaction also. What may be the option? What will happen to sulfur state of sulfur? You're having sulfur dioxide, means you're having a K2CO2O7. What is K2CO2O7? So it's an oxidizing agent, already we have discussed. It's a very strong oxidizing agent. So it will oxidize SO2. So what will happen when SO2 gets oxidized? It becomes sulfur. What may be option? Sulfate, SO2 gets oxidized to what, sir? It becomes sulfates. What sulfate? H2SO4. The SO2 gets oxidized to form what? Sulfuric acid, sir. And K becomes, sir, K2SO4. And chromium becomes, sir, Cr2SO4 thrice. Or thrice. Plus what we get is H2O, sir. H2O. So what will be the option? Let us find out in SO2 what is the oxidation state. So how to find out? Already I told you. The total oxidation number is 0. And you don't know S. How many oxygen is there? 2. And oxidation state of oxygen is -2 is equal to 0. So S is equal to what, sir? +4. S is equal to +4. So it changes from 4 to what it changes. Let us take K2SO4. What is the oxidation state of sulfur here? We don't know, sir. Yes, we don't know. Potassium, 2, sir. plus oxygen, sir, -8 is equal to 0. So S is equal to what, sir? We get +6, sir. So that means it changes from +4 to +6 state. Whether the option is there, sir, anywhere, +4 to +6. Yes, sir, option is A. Option is A. Next one. Which of the following is the maximum number of unpaired d electrons? Maximum number of unpaired d electrons. One by one we will start it. We can start with nickel 3 plus. Yeah. So he says nickel and nickel 3 plus. What is the atomic number? Sir, 28. So it's a argon 4s0, 3d8, 3d8. But here nickel is in 3 plus state, sir. 3 plus means you have to remove 3 electron. Remove 3 electron. So this is 4s2. So 4s0 it becomes, and one more electron, 3d7, sir. 3d7 means you arrange it in a d orbital. D orbital is having 5 suborbitals. 1, sir, 2, 3, 4, 5, 6, 7. So unpaired electrons are 3, sir. Like that, we'll go to copper. Copper is in what state, sir? +1 state. +1. What is the atomic number of carbon? 29. 29 means it becomes what? You remove one electron. 4s. So 4s1. And 3d9, it becomes 3d10. 3d10. This becomes what? 4s0 it becomes. 4s0. So no unpaired electron. So both option, let us keep it then. Let us go to D. What is D, sir? You are having iron. Iron is in what state? +2 state. So what is the configuration? It becomes 4s0, 3d6. 3d6 means in D there are 5 suborbitals, sir. Let us arrange it. 1, 2, 3, 4, 5, 6. And now N is equal to how many? 4, sir. That means D is the option, sir. Next, incorrect statement in respect of chromal chloride test is. What is the incorrect statement? What is a chromal chloride test? We do it during the detection of chlorine or confirmation test for chlorine. We do it. How we do it? Say you're having a salt with chlorine atom. Say you're having NaCl. What you will do? You will take crystals of potassium dichromate and you will add sulfuric acid. When you add sulfuric acid, you get a red vapors. And these red vapors are known as chromal chloride, CrO2Cl2. So what he says, the incorrect statement in respect of chromal chloride test is, he says formation of lead chromate. That is right only. Why, sir? At the end, what we do now, we pass it through NaOH solution. When you pass it through NaOH solution, it becomes a sodium chromate, Na2CrO4. And to this, you add lead acetate. You will add lead acetate. When you add lead acetate, what will happen? They get converted into lead chromate, PbCrO4. PbCrO4 is a lead chromate. That means right. So the first option is right. Formation of chromyl chloride. This is the chromyl chloride. Yes, sir, that is also right. Formation of chlorine. Wrong, sir, we don't get chlorine. Formation of red vapors. Yes, sir, red vapors we get it. Right. So option is C, sir. Option is C. The magnetic moment of a transition metal ion is 15 bm. Therefore, the number of unpaired electrons present in it is. How we calculate magnetic momentum? Mu is equal to a square root of n into n plus 2. N plus 2. So we know that if n is equal to 3, n is equal to 3, what will happen? This becomes 3 into 3 plus 2. That is 3 into 5. That becomes square root of 15. So, yavaga when n is equal to 3. So option should be, sir, D answer. Next one. The spin-only magnetic momentum of Mn4 plus ion is. So how to calculate Mn4 plus ion? So let us take atomic number of manganese. So 25. 25 means argon. So 4s2, 3d5. 35. And he says Mn4 plus. Mn4 plus means what? You have to remove 4 electron, 21. Then it becomes argon, 4s0. So again 2 electron remove. It becomes 3d3. 3d3. 3d3 means we know that n is equal to 3. Just now we have done now. If n is equal to 3, then magnetic momentum is equal to what? Square root of 15. Square root of 15 means, sir, it is around 3.89. That is almost equal to 4, sir. 4 means what? Sir, option C. Option C. Yes, sir, option C it is. A white crystalline salt A reacts with dilute HCl to liberate suffocating gas B and also forms yellow precipitate. The gas B turns potassium dichromate acidified with dilute sulfuric acid to green colored solution of solution C. A, B, and C are. What is this one? A white crystalline salt A reacts with dilute HCl to liberate suffocating gas. Suffocating gas is SO2. SO2. That means your compound should be Na2S2O3, which reacts with HCl to liberate water, sulfur dioxide gas. This is suffocating. This should be B and this should be A. And this, he says, this gas B turns potassium dichromate. What is potassium dichromate? So K2Cr2O7. Potassium dichromate is orange color. Into yellow precipitate. Yellow precipitate. Because SO2 gets oxidized to what? Sulfur. Yellow precipitate. Then he says it to green colored solution. Why green colored solution, sir? Because you get chromium sulfate, Cr2SO4 thrice, SO4 thrice. This is green color. You get along with that, you get K2SO4. But this is what very, very important. So this should be C. This should be C. So A, B, C is what, sir? Na2H2O3, SO2, chromium sulfate. Sir, option is B. B is the option. The yellow precipitate formed during the chromium chloride test is chemically. Again, I told you, chromium chloride is a test for what? Chlorine. Confirmation test for chlorine. So imagine you're having the salt of chlorine, NaCl. What you're adding? Sir, you're adding potassium dichromate, K2Cr2O7. Plus you're adding sulfuric acid. I told you get a red vapors. What is red vapors? Red vapors are chromium chloride, CrO2, Cl2, sir. And these red vapors, what you add? You add lead acetate. Sorry, first you add NaOH. What you get? Sir, you get Na2CrO4, sodium chromate. To this, you add lead acetate. When you add lead acetate, I told you, you get a lead chromate, PbCrO4 you get. This is yellow PPT. Yellow PPT. Sodium chromate is a yellow solution. Yellow solution. So what will be the option? So yellow is due to lead chromate. Lead chromate means, sir, option again B. B, sir. Next one. The spin-only magnetic momentum of Fe2 plus ion is. What will be the option? Spin-only means magnetic momentum of Fe2 plus ion. We know that Fe is what? Sir, 26. Atomic number is 26. E says Fe2 plus. Fe2 plus. Means what we get? We get 4s0, 3d6 we get. 3d6. 3d6 means what? N is equal to 4. N is equal to 4 means mu is equal to square root of N into N plus 2, sir. That means what you get? Square root of 4 into 4 plus 2. That is 24. Square root of 24 means almost is around 5, sir. 5 it will come. Which is 5? Sir, option C. Next one. So which one of the following has a magnetic momentum of 1.75 Bohr's magneton? What will be the option? We have to get 1.75. We know that N is equal to 4 means we get 24. N is equal to 3 means we get square root of 15. So that means this has to be N is equal to 1, sir. N is equal to 1. So where we get it? Let us check it out. So one by one we started. Where we started? We started with titanium. So titanium. Titanium is, sir, how much? It's a 22. Means argon 4s2 and 3d2, sir. E says titanium is present in 3 plus state. 3 plus means you have to remove 3 electrons. That means 19, sir. Let us remove 3 electrons. From 4s0, so 2 I am removed and 3d1. Yes, sir. Here N is equal to 1. N is equal to 1. That means mu is equal to, sir, what do you get? 1 into 1 plus 2. That is, sir, square root of 3 we get. That is 1.78, sir, 75. So option is, sir, A option is. Next one. So the spin only magnetic momentum of nickel 2 plus in aqueous solution is same way we have to do it. That's it. First, we have to write it for nickel. Nickel is what? 28. So nickel is 28. 28 means what? Sir, argon. 4s0, 3d8, sir. 4s2, 3d8. He says nickel 2 plus. No. Nickel 2 plus means you remove 2 electrons. So it becomes argon 4s0, 3d8, sir. It becomes 3d8. 3d8 means n is equal to 2, sir. So mu is equal to 2 into 2 plus 2, sir. Is nothing but square root of 8. Square root of 8 means, sir, it is the option D. Next one. So silver iodide is used for producing artificial rain because of what? What it will do? It will increase the surface area because the crystal is almost similar to ice. So option is C. Which one of the following shows highest magnetic moment, sir? Highest magnetic moment. Similarly, we have to calculate mu is equal to n into n plus 2. Let us take one by one. Sir, we have what? Cobalt in 2 plus state, sir. Cobalt in 2 plus state means what you get? The configuration becomes 4s0 argon, 4s0 3d7. 3d7 means here n is equal to 3. What is the next one? Sir, Cr3 plus. Chromium 3 plus. It becomes what? 4s0 3d3. Again, n becomes is equal to 3. Then you are having nickel 2 plus. Nickel 2 plus we have done. Just now we have done. Nickel 2 plus. What do you get? 4s0 3d8. 3d8 means, sir, n is equal to 2. Let us come to iron, sir. Iron is what? Plus 2 state. This also we have done. So this is nothing but 4s0 3d6. 3d6 means n is equal to 4, sir. So highest is iron, sir. Iron means what? Option E. Option E is. So in transition series with increase in atomic number, the paramagnetism, what will happen? First increases, it becomes D1, D2, D3, D4, D5. Then it again decreases. What is the option? C, sir. IUP is the name of the complex ion formed when gold dissolves in aqua regia. What is aqua regia? It's a mixture of nitric acid and HCl. So nitric acid and HCl. In that only gold will. What is gold? Gold is AU. AU. So when it dissolves, it forms a complex. What is the complex? It forms HAuCl4, sir. Cl4. That's what we get. So nitrazil chloride and water we get. So what is the name of this compound? That's what he's asking. How many chlorine is there? Sir, 4 chlorine is there. Tetrachlorido. So tetrachlorido. And gold we should call it as R8. R8. What is the oxidation number here? It is 3, sir. What is the option? Option in that what they are given is, sir, A. Option A is the answer. Which one of this is not known? What is not known? So we don't have Cu2I2. So B option is not known. The correct statement, what is the correct statement in this one? The earlier member of lanthanide series resemble calcium in their chemical properties. Yes, sir. The extent of actinide contraction is almost same. Wrong, sir. Actinide is more than lanthanide. In general, lanthanide and actinide do not show variable oxygen state. They show +2, +4, they show it. Cerium 4+ in aqueous solution is not known. Okay, tappu. Cerium 4+ is known. So the correct statement andre onde ondagutte. Option A. Next, a salt MsO4 reacts with NH4OH to form X. X reacts with ammonium hydroxide to form Y. Y reacts with H2S to form Z. So what may be the metal is asking? What may be the metals? Usually, the copper and zinc are deposited as sulfides. For example, they can be taken as zinc sulfide. When you do this qualitative analysis of salts, you do it where you do analysis of basic radical. Only group test ಮಾಡಬೇಕಾದ್ರೆ ಇದು ಮಾಡ್ತೀರ ನೀವು. So imagine you are having a zinc sulfate. ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಅದನ್ನ ಅದು ಸ್ವಲ್ಪ ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಹಾಕ್ತೀರಾ, ಅದೇನಾಗುತ್ತೆ ಅಮೋನಿಯಂ ಜಿಂಕ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಆಗ್ಬಿಡುತ್ತೆ. OH twice. ಅದಕ್ಕೆ ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಎಕ್ಸೆಸ್ ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತದೋ ಇಟ್ ಬಿಕಮ್ಸ್ ಎ ಕ್ಲಿಯರ್ ಸೊಲ್ಯೂಷನ್. ಮತ್ತೆ ಅದಕ್ಕೆ ಸ್ವಲ್ಪ H2S ಹಾಕಿದ್ರೆ ಜಿಂಕ್ ಸಲ್ಫೈಡ್. So option is yes, sir. Option A. The electronic configuration of GD is. What is GD? So it's a lanthanide element. What is the configuration is asking? So it's a half-filled stability it is having. That means half of it. Half of it means 4F7. Then, sir, it is having 5D1. Option B, sir. On eating potassium permanganate, one of the following compound is not obtained. What may be the option? We need potassium permanganate. What is permanganate? KMnO4. So permanganate gives you manganate. What is manganate? Sir, it's a K2MnO4. So we get manganate, sir. And we also get manganese oxide. That is MnO2, sir. So what we don't get, sir, MnO, we don't get it. So the option is, sir. The bivalent metal ion having the maximum paramagnetic behavior among the first transition series element is. That means more unpaired electron means more paramagnetic behavior. More unpaired electron means more paramagnetic behavior. So what may be the option? We know that in a manganese, what is manganese? What is the atomic number? Sir, manganese atomic number is 25. Sir, argon 4s2 3d5. And you say Mn2 plus. Mn2 plus means argon. So 4s0 3d5. 3d5 means sir, n is equal to 5. So this is the maximum you can get. So option is A only, sir. Option A. So when a brown colored manganese compound is treated with HCl, it gives a gas B. It gives a gas B. The gas is taken in excess, reacts with ammonia to give an explosive compound. So what is explosive? ಈ ಕೊಟ್ಟಿರೋ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ನೈಟ್ರೋಜನ್ ಟ್ರೈಕ್ಲೋರೈಡ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಅದರಿಗೆ NCl3 ಇದೆಯಲ್ಲ ಅದು ಎಕ್ಸ್ಪ್ಲೋಸಿವ್. This is explosive. NCl3 ಎಲ್ಲಿದೆ? So there are two options, A and B. A and B. So what has to happen? First we have to get chloride. Chloride ಸಿಗ್ಬೇಕು ಅಂದ್ರೆ ಏನಾಗಬೇಕು ನಮ್ಗೆ? ಈ ಆಕ್ಸೈಡ್ಸ್ ನಾವು HCl ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಬೇಕು. ಯಾವ್ದು ಆಕ್ಸೈಡ್ ಸರ್? ಮ್ಯಾಂಗನೀಸ್ ಆಕ್ಸೈಡ್ HCl ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ ಮ್ಯಾಂಗನೀಸ್ ಕ್ಲೋರೈಡ್ ಸಿಗುತ್ತೆ ಸರ್ ನಮ್ಗೆ. ಮ್ಯಾಂಗನೀಸ್ ಕ್ಲೋರೈಡ್ ಸಿಗುತ್ತೆ ಪ್ಲಸ್ ಕ್ಲೋರಿನ್ ಸಿಗುತ್ತೆ ನಮ್ಗೆ. ಆ ಕ್ಲೋರಿನ್ಗೆ ಅಮೋನಿಯಾ ಹಾಕಿದಾಗ ಈ ಕಾಂಪೌಂಡ್ ಬರುತ್ತೆ ಸರ್, NCl3. So the B is chlorine, A is manganese oxide, and C is NCl. The option is A, sir. (28) Sir, Mn2 plus compound are more stable than Fe2 plus towards oxidation to the +3 state. Why it is like this? Just now I told you. What is that? Sir, in Mn plus 2, what is the oxidation state? Argon 4s0 3d5, sir. 3d5 means what? So it is having a off-filled state. Off-filled means stable third. Stable it is. So what is the option? Sir, option A again. Which of the following statement is wrong regarding lanthanides? What may be the wrong? Lanthanide compounds are predominantly ionic. Yes, sir. Lanthanide hydroxides are mainly basic. Yes, correct. Ionic size of lanthanide ion decreases due to lanthanide contraction. Lanthanide 3 compounds are colorless. Wrong. They are colored. Option D. Which of the following is amphoteric oxides? Which of the following is amphoteric oxides? Amphoteric means which should bear both as an acid as well as a base. So V2O5 is amphoteric, whereas Mn2O7, more the oxidation state, it is acidic in nature. So we cannot take Mn2O7. So B cannot be. So chromium oxide, CRO, lesser the oxidation state, it is basic. So we cannot take B and C. So option should be, sir, A and D. A and D. Sir, option is A, it is. Which of the following common oxidation state is common in all lanthanides? Lanthanides can have only 3. So which are those? +2 and +4. and in between +3. The common is +3 only. +3 means, so it is option B. Sir, Bhagati, sir, is there? Are you there?
Yes, sir. Yes, sir.
Shall we conclude now?
Yes, sir.
Okay, then. We'll
Thank you
conclude
so
it.
much, sir.
No problem.
Dear students, we are ending chemistry class now. Again, you must be having Thursday and Saturday, sir.
Yeah, right.
Okay. Tomorrow, as usual, there will be a class. Tomorrow, mathematics class will be there. Sir, these notes you will be sharing. I will share the notes and recordings in the group. Any friends who did not attend, you can ask them to just watch recording. Thank you so much. I'm happy that you are very interactive. You are putting so many questions. You are putting your answers to the questions. If any clarification or anything you require, you can WhatsApp me. Thank you. Happy learning, students.